Particularly here, I like this some rules because one person is able both of them are
Can you ask Professor if he has any opportunity to talk about this? And have you left IIT or you're still within the campus?
they have to come
Then you
here
can
and
come via the incubation center. That will be easy. You just ask something. Or you can put in map. You come via incubation center, so you reach near the paramedics. Just ask for
Good morning and a warm welcome to one and all. I request our director to invite the chief guest of honor of today's event, directors of sister laboratories and other dignitaries to adorn the dais. Chief guest of today's function, Professor Ravindra Gettu, V.S. Raju, Chair, Professor, IIT Madras. Guest of honor, Professor Prasad Rao Rangaraju, Clemson University, USA. Dr. N. Anandavalli, Team Director, CIE Team and Director, CSAR, SCRC and Coordinating Director, CMC. Professor R. Pradeep Kumar, Director, CSAR, CBRI. Professor Manoranjan Parida, Director, CSAR, CRRI. Dr. S. Parivalal, Chief Scientist and Advisor Management, CSAR, SCRC. Dr. P. Harikrishna, Chief Scientist, CSAR SCRC, Dr. Saptarishi Sasmal, Chief Scientist, CSAR SCRC, Dr. Amal Prakash, Senior Principal Scientist and Nodal Scientist for CIE team, invitees from government organization, academia and industry, all the staff members of various CSAR labs, colleagues and friends, I welcome you all for the 1 week, 1 theme event for Civil Infrastructure and Engineering Team 2024. We shall begin the function with Tamil Thai Vartal. May I request all of you to please raise. I now request all the esteemed dignitaries to kindly light the Kuttuvelakku, marking the commencement of our event. I now request Dr. Amar Prakash, Nodal Scientist, CIE team, to deliver the introductory address.
Respected dignitaries on the dais, my senior colleagues from CSIR, SERC, present here, and those who are connected online, invited guests from industry, press and media, well, a very good morning to all of you. Indeed, today is a very special day. This is 5th September and we are celebrating Teachers' Day. So I wish all the teachers present here and those who are connected with us a very happy Teachers' Day to all of you. So I am standing before you to introduce this event, which is 1 week, 1 theme for CIE theme actually. So I will give you a brief introduction about what is this event about. So Council of Scientific and Industrial Research, CSIR, I think everybody is aware here. So I will not give much detail. Then coming to this particular 1 week, 1 theme, I will say this event is launched on 24th June by Honorable Minister for Science and Technology and Earth Sciences, Sri Jitendra Singh ji. And this campaign actually an initiative to showcase our R&D efforts and India's strides in the science and technology. And this campaign is indeed a direct reflection of Honorable Prime Minister's vision to extend scientific advancements beyond laboratory confines. So the main thing is that whatever laboratories we are doing, it should reach to the common man. So considering those important aspects of research and development, these events are being organized. So this event is for 1 week actually, from 2nd September to 6th September, and this is the 4th one. The first one inaugurated in Delhi. After that, second event happened in Gujarat, Science City. That was on 3rd September. And 4th September, we had organized in CMERI Durgapur. And today, this is the one here. And after that, it will be concluded in Bhopal. So one of our laboratory. So basically, we are 5 labs of CSIR out of 39 laboratories, 38 laboratories, which are expertise in this domain of civil infrastructure and engineering. So they together they are contributing towards these events and uh, arranging the organizing events through exhibitions, presentations, and meetings with the stakeholders. So the main objective is that all should come together to take the R&D efforts to the common man. Further, as we know that when we are working in an organization, we have to be like unity and diversity both together. So here what they have done, they have come out with 8 themes in whole CSIR. Out of that 8 themes, CIE theme, which is civil infrastructure and development, is one of them. So that under this theme, then there are sub verticals which CI theme sub-verticals to classify the work in such a way that this is not duplicate or it's not like a duplication of work. So they have unique features, unique aspect to focus on. So these sub-verticals are building physics and materials and rural infrastructure, mobility infrastructure and planning, structural health monitoring and life extension, disaster mitigation for infrastructure, automation and robotics, waste to wealth. So under these 7 sub-verticals, all the R&D efforts are taking place in this CSIR system. So here these events under 1 week, 1 theme campaign are expected to attract a diverse audience, including stakeholders such as MSME, startups, self-help groups, and research community. The main objectives of this campaign is to create awareness among citizens and along with this knowledge sharing to facilitate the exchange of insights, advancements in civil engineering, what is happening in the labs, and technical demonstrations. So people that from the scientists are demonstrating their technologies to the exhibitors or participants, research gap identification. The another main aspect through the interactions with the stakeholders, we come to know that what is their actual requirement and where we should focus further to meet the requirement and demands. And then stakeholder engagement from policymakers, regulatory officials, and government organizations is also being happened during these events. So this ongoing 1 week, 1 theme event, that is the campaign of Government of India under CI theme that promises a significant platform for advancing knowledge and addressing the challenges in civil infrastructure and engineering. The insight and collaborations fostered during this campaign will be instrumental in aligning research outcomes with practical needs, ultimately supporting the creation of resilient and sustainable infrastructure. With this brief introduction, I will stop. Thank you very much.
Thank you, sir. I now request our director to welcome chief guest of today's event, Professor Ravindra Gettu, with a plant pot. And I also request Professor Manoranjan Parida to welcome our chief guest with a shawl. I now request our director to welcome our guest of honor, Professor Prasadrav Rangaraju, with the plant pot. And I also request Professor Pradeep Kumar to welcome our guest of honor with a shawl. I request our director to welcome Professor Pradeep Kumar with the plant pot and Dr. Hari Krishna to welcome our director, CBRA, with a shawl. I request our director to welcome Professor Manoranjan Parida with a plant pot, and also I request Dr. Saptarishi Sasmal to welcome director with a shawl. I now request Dr. N. Anandavalli, Team Director, CIE Team, and Director, CSIR SCRC, and Coordinating Director, CMC, to deliver the welcome address.
Vanakkam and Namaskar. It is indeed a great honor and to welcome our chief guest, Professor Ravindra Gettu, who is known to us. He is not known to our campus. And also Professor Prasad Rangaraju from Clemson University. Welcome you both, sir. I thank them for taking off time from their busy schedule to attend this. And we are also expecting Professor Hemant Dolai from Melbourne University. He'll be joining shortly. So, all audience present here, industry partners, stakeholders, present media, my brothers and sisters of this campus, Vanakkam. And as Dr. Amma Prakash has highlighted upon what is the event all about, 1 week, one theme. So I'll be just giving a small introduction of what are all the different verticals and how we are progressing. So as we all know, civil infrastructure and engineering is always connected with our lives. Next slide, please. And today today I would like first of all to greet my teachers and all teachers who are present here. Happy Teachers Day. And this month, again, another great civil engineer of this nation, Dr. Visvesvaraya, was born on 15th September, and in that connection, we are celebrating the National Engineers Day. So most of us are civil engineers, and we should take pride that we all should follow the footsteps of him as well as take pride in his contributions. So we chose this month, basically. We were given an option and we chose this month to celebrate the civil infrastructure and engineering theme. And we plan to declare 15th September as the theme day. So CIE theme day. So with that note, so all of us are aware that infrastructure globally as well as India, there are a lot of requirements. And welcome Professor Hemanta. Then I request Dr. Pari to honor. So infrastructure is backbone of any nation, and in terms of power, water supply, communication, roads and bridges, ports. So, and it constitutes about 14% of the global GDP. And also housing is another major sector where a lot of investment is there. So this particular theme will be addressing all these requirements. So coming to the national scenario, if you see, again in the budget, last year's budget, I think there was 35% increase in the capital expenditure, and PM Gati Shakti, which addresses there are different aspects which is relevant to this particular theme, say roads, railways, airports, mass transport, ports, waterways and logistics, and some of the GOI missions like housing for all, smart cities. All these are we can address from this particular theme. We can contribute a lot to the nation's development. And as we all know, the basic necessity is shelter, which has to be safe, sustainable, and environmental friendly, both urban as well as rural. And mobility, which is should be planned and durable. Different forms of connectivity, roads, bridges, railways, and waterways. And we need to monitor any prevention of any unwanted events and mitigate the natural and man-made disaster, and automate for quick implementation and address the waste generation towards circular economy. So all these are part of the Gati Shakti master plan, and this particular theme addresses from energy to environment, materials to infrastructure, sensors to robotics. And our aim, vision is to become a forerunner in this particular domain by embracing innovative inter and transdisciplinary approaches, and for the growth of civil infrastructure and providing high value services to the industries and society at large. So we are keeping these aspects in view. We are having 7 verticals, sub-verticals, and each vertical is led by a particular lab. So coming to building physics and materials and rural infrastructure, it is led by CSIR, CBRA, and some of the developments are like UV ventilation or bamboo reinforced concrete structures, cost-effective toilet units, and net zero energy buildings. And mobility infrastructure and planning, it's led by CRRI, Central Road Research Institute, and Steel Slag Road, which I think tomorrow they are laying in Tenkasi. And this is a very good development. Waste to wealth, again we can tell. And road safety audit, and from our own CSR, SCRC, we have textile reinforced concrete fencings. And coming to the next vertical, automation and robotics, it is led by Central Mechanical Engineering Research Institute, and some of the developments are a mechanized sewage lining cleaning system, like this is keeping society in mind, and also some cooking systems. And the next vertical is waste to wealth, which addresses in turn sustainability as well as circular economy. So from agro waste and industrial waste, number of products like concrete blocks or building products, tiles, all these are developed. And this particular vertical is led by Advanced Materials and Processing Research Institute, Bhopal. And coming to the sixth one, structural health monitoring and life extension, and disaster mitigation for infrastructure, both are led by CSR, SCRC. And structural health monitoring, including railway bridges, highway bridges, and dams, we contribute, and also development of new NDT techniques. And coming to the disaster mitigation, both man-made as well as natural hazards, we address that, and we are also involved on the offshore floating wind turbines and solar farms. So some of the achievements I'll be highlighting. One is we are all proud that this theme has contributed to the Ayodhya Sri Ram Mandir, and the CBRA was taking lead. And geopolymer concrete pavements and bamboo houses in terms of rural infrastructure, and modular lightweight wastewater treatment units with TRC. And I think Professor Getu was part of this particular Indo-German collaboration. And mobility infrastructure, steel slag road, and also the TRC fencing. These are only one or two examples. A lot more can be, we are having an exhibition outside which will talk more about what are all the developments of the individual labs and the verticals. And coming to the next vertical on waste to wealth, the Perelli board to address the agro waste, and this is a number of products have been developed, and also red mud, using red mud radiation shielding tiles as well as doors have been developed. And automation robotics, compact electric tractor, and mechanized drain cleaning system, and number of robots and cobots are developed in this particular vertical. And coming to the structural health monitoring, the recent new Palmer Bridge, ACRC is involved with the health monitoring of that, and we also for the lift span deflection check, we have done it, and then we are also involved in the health monitoring. And integrity of the spillway structure of Polavaram Dam, that is again a contribution from our side. And a number of railway bridges, health monitoring was done. And condition assessment of Tapovan Vishnugad, which was destroyed during the flash floods, and this hydropower project, we have the condition assessment was done, and we have recommended the remedial measures. And coming to Joshimath, mitigation, recovery, and reconstruction was done. And emergency retrieval system is a technology developed by CSIR SCRC, where this is particularly useful for power line, transmission line towers during a cyclone disaster to immediately restore the power. This will be very useful. This is an indigenous development, and it around 40% cost saving is there. And we also have worked out what we'll be concentrating in the next few years. So some of the things in the long term also we have planned. And under building physics and materials, at the end we want a net positive energy building and self-healing materials and meta materials. These are some of the aspects. I'll not be reading out in total. So the second one on the rural infrastructure, cold mix technology for high volume roads, and also innovative designs to use various localized materials. And bamboo is another area where we'll be concentrating, and geopolymer contributed. And coming to the mobility infrastructure, and the drone can be used for assessment, road assessment, and as well as in the long range, we would like to have a autonomous vehicle operation for Indian traffic condition, and also drone-based automatic road safety audit system. And coming to automation and robotics, so in the long term, we would like to have a developed and fully connected and intelligent cobots and digital twin for in-situ certification, and also power electronics, and for some of the developments for unknown and unpredictable environments, how to automate as well as how to use robotics to assess. And coming to waste to wealth, so in the long run, we'll be concentrating on multi-attribute optimizing processes to develop cost-effective buildings, materials using industrial waste. Towards that, we are working, and short and long mid-term goals are fixed up accordingly. So in the structural health monitoring and life extension, we would like to have cyber physical system for SHM, including IoT, ICT, and industrial internet of technology, and also digital twin. This is the long-term plan, and towards which we are working. And also standards. Right now, we need a number of standards for the SHM, and this will be also we'll be concentrating. And coming to the disaster mitigation, in the multi-hazard risk reduction in the long run, and using AI and ML techniques, and also how to re-engineer for the climatic change. These are all some of the aspects which we'll be addressing. All these are mapped with the SDGs and also the GOI missions. So with that, I welcome you all once again to this 1 week, 1 theme, which is planned here at SCRC. And I would like to conclude with a Thirukural, which goes this way: Pini inmai selvam vilevi inbam emam ani enba naattirku iva indum. So a country's jewels are 5: unfailing health, fertility, and joy, and assured defense and wealth. And together we'll all contribute to make our nation a Vikshit Bharat. Thank you.
Thank you, ma'am. I now request Professor R. Pradeep Kumar, Director, CSIR CBRI, to deliver his address.
Chief guest of honor, dignitaries on the dais, and guests who have come to witness this 1 week, 1 theme campaign.
good morning to you all. So already Dr. Anandavalli, Director SCRC, has given the details about this theme, but I'll go a bit deeper into it. That is, CSIR was established in 1942. It's more than 80 years till now. And recently it was felt that across 37 laboratories, what has been done and what CSR has contributed through its 37 laboratories is known to people very less. So that's why Honorable Minister Dr. Jitendra Singh ji started this campaign of 1 week, 1 lab. So this campaign was a year-long campaign. Last year it started, and then after that, as a follow-up campaign, he initiated this 1 week, 1 theme, because all 37 laboratories are divided into 8 themes. So that's what Madam explained just now. So now the question is, whatever R&D laboratories are doing, it has to reach public. And R&D labs reaching public is not that easy directly. So in between, industry is there. So industry, academia and R&D and government. So these three entities have to work together to give benefits to society. So that is very, very important. If I give you a brief background on these things, see, earlier, long back, maybe 1,000 years back or 1,500 years back, religious institutions used to give direction to society. Then slowly that changed, and the direction started coming from governments, means kings and emperors. And after that, in recent times, last say maybe few decades, industry is driving society. So industry has a very strong connect with society. But if any one entity driving society will lead to society with lot of imbalances. That's what we are seeing. And if I start counting problems, you see many problems are there, countless number of problems. Now this is opportunity for us where again government, R&D institutions and industry work together, and ultimate aim is what for industry? Two things. One is make profit, definitely make profit, but at the same time serve society. So it is for us together understand what R&D institutions are doing, where new businesses can come, where the current business can be enhanced, and where handholding is needed from industry to R&D institutions and from R&D institutions to industry. So all these things, a platform is set up for this one. So this 8 themes across 37 laboratories is doing this massive campaign. And as you all know that we are standing at 5th position in the economy, that you know. To go towards say 4th position and 3rd position, it may be slightly difficult, but we'll reach very soon. But from there to achieve second largest economy, that is a very big jump. It is 6-fold increase. And to achieve first slot, we generally say we have to reach number 1 position. It is 10 times. We have to increase our economy right now 10 times. So that means what? R&D organizations like all of us and industry. So you are visiting and witnessing. We need to think together how to reach such kind of targets. So then only we will be able to give a better living standards to our citizens. So I'm expecting this will happen through 1 week, 1 theme program. And thank you very much for giving me this opportunity to speak. Thank you.
Thank you, sir. I now request Professor Manoranjan Parida, Director, CSIR CRRI, to deliver his address. Please, sir.
Thank you. So at the outset, I would extend a warm welcome to Professor Ravindra Gettu, Chief Guest of the program, Professor Rangaraju, who is the Guest of Honor, Professor Hemant Dalai, Guest of Honor, Dr. Anandavalli, the Theme Director of Civil Infrastructure Engineering Theme, and host for today's event at SCRC Chennai. Special compliments to you and the entire SCRC team to host this particular event, and also the week-long event which started at Delhi. Other dignitaries on the dais, off the dais, all visiting scientists from all the participating institutes, professors from different academic institutes. So, as Madam said, today is 5th September, Teachers' Day. There are a lot of teachers here. In fact, our scientists from different CSR institutes, they have affiliating position as different teaching positions in ACSR. So, a happy Teachers' Day to all of you. And very aptly, we have picked up September to celebrate the 1 week, one theme of civil infrastructure engineering. So I'll not repeat what my previous speaker said, but Dr. Anandavali closed with a quote where there was mention of wealth, like the nation will prosper, obviously with wealth, the GDP needs to grow. So I'm from Central Road Research Institute, director of the institute. So I just get back to one quote which maybe you must have heard. While the highway development is taking place, more often people are using that quote. So it is the quote by John F. Kennedy. American roads are good, not because America is rich, but America is rich because American roads are good. So with the second largest road network in the world, I'm sure any development in mobility infrastructure, roads, ports, highways, bridges, railways, we are going to prosper. So that's the kind of the expectations. And there are different verticals. Largely CRI works in mobility and infrastructure planning verticals, and this particular theme, it helps us to organize our activities. Like currently what we are doing, and most of the activities are aligned with the national priorities. Especially, I would like to give few of details of our activities. Under Waste to Wealth, the institute has been very active with respect to various industrial waste that includes the industry from the steel slag waste, then the red mud waste from the alumina industry. But we are also utilizing municipal solid waste using waste plastics, and currently trying to convert the biomass to biobitumen. In fact, these biobitumen, they can help in reducing bitumen import by almost 30%. So as my previous speaker said, one of the goals of the CSR Institute has been into translational research, and we work very closely with industry, with academia. So at Central Road Research Institute, we have developed Indian Highway Capacity Manual, so which is like a 6-year project, and CRI was the nodal agencies. 3 IITs were partners: IIT Roorkee, IIT Bombay, IIT Guwahati, SPA Delhi, IAST Kolkata, and Anna University. So these academic institutes were picked up all across the India, and very recently we have released the trip generation manual for 32 cities in India. So again, there are 8 academic institutes which partnered with CRI for this kind of project. And very recently we have received the PG grading of bitumen, which is a very important project. It is along with IIT Delhi. So this is one idea that these partnerships are extremely useful even for the translational research activity. Typically, academic institutes, there is definitely going to be a bit of thrust on academic research, but with these kind of live projects, it is very much useful to orient the research towards translational in nature. The Indian Highway Capacity Manual has resulted in 48 PhD theses and more than 100 high-quality publications. Besides the manual, the document was released by Honorable Minister of Road Transport and Highways. And just to give glimpses of certain activities in mobility infrastructure, the National Test Facility for Expansion Joint, the project is almost getting completed at Central Road Research Institute. So it is going to be a facility of very unique nature. Besides the research, we are also into certification, into testing, and facilities which are not existent in the country, like the labs have a mandate to develop those kind of facility. This, I mentioned about the biobitumen, that project is now picked up in association with another sister lab, IIP Dehradun. Like while we are celebrating OWOT, these 5 CSR labs are the major institutes, but we have collaborations with other CSR institutes also. Like CRI works with NPL Delhi, it works with NIRI Nagpur. We work with a number of labs, like for self-healing pavement. Even we are collaborating with NCL Pune. So besides the labs in the OWOT theme, we are also interacting with other labs. So the basic idea of these week-long celebration is to share the details of our activities, to go into the public domain, and to seek further collaboration. We have been working with different government institutions, industries slowly picking up, and the basic thrust is going to develop new technologies, innovate new ideas, which can be very useful with respect to the various development which is taking place around that. And with this, I thank you all for kind attention, and I'm sure the day-long deliberations will be extremely useful to you. Feel free to reach out to all of us in case if there is any query. We'll be very happy to address them. So once again, thank you all for joining this program. Thank you.
Thank you, sir. I now request Dr. Parivalal to introduce the chief guest of today's event.
So, good morning to everyone present here. I am happy to introduce our chief guest, Professor Ravindra Gettu, who has warmly accepted our invitation to join us today this one week, one theme event. Professor Ravindra Gettu is currently V.S. Raju Chair Professor in Department of Civil Engineering at Indian Institute of Technology, Madras, Chennai, and he has contributed significantly to teaching, research, and administration in the Department of Civil Engineering. He has graduated from Government College of Technology, Coimbatore, with a BE Honours degree in Civil Engineering from the Madras University, and he is a fellow alumnus of myself. He later studied in the USA and obtained as MS degree in Civil Engineering from Marquette University, Milwaukee, and a PhD degree in Structural Engineering from Northwestern University, Evanston. In 1990, Dr. Gettu moved to Barcelona, Spain, and later became the Director of Structural Technology Laboratory of the University Politècnica de Catalunya in the School of Civil Engineering of Barcelona. Since 2004, he has been at Indian Institute of Technology, Madras, Chennai. Dr. Gettu's area of research are fracture mechanics of concrete and rock, nonlinear behavior of cement-based materials, high-strength fiber-reinforced and self-compacting concretes, sustainability, and the effective use of chemical admixtures. He has co-authored close to 500 publications, of which more than 100 are peer-reviewed journals papers. He has been an associate editor of the Materials and Structures Journal and is the editorial board of several other journals. Dr. Gettu was honored for outstanding contributions at Gettu Kudur Symposium on Advances in Science and Technology, Concrete, in 2018, and the third International Conference on Sustainable Construction Materials and Technology in Japan, 2013. He was elected as Fellow of Indian National Academy of Engineering in 2018. He is a Fellow of Relium and has been a member for several technical committees. Dr. Gettu was elected Relium Vice President in 2015 and President from 2018 to 21. And the Relium outgoing President from 2021 to 24. He was elected as foreign member of Russian Academy of Engineering in 2019, and he is a core member of the UN Environmental Network, Low Carbon Cementitious Materials, and part of UNE 10-year framework program on sustainable building and construction. And he has a lot more to say, but right now I will stop with that and request Professor Gettu to.
Thank you very much for the kind introduction. So first of all, I'd like to thank Dr. Anandvalli for the invitation. Thank you, ma'am. And the directors, the other directors who are here, Dr. Pradeep, Dr. Parida, both of whom I know well as great leaders, and it is very evident that the three major labs in civil engineering are in very good hands. Fellow dignitaries here off the dais and on the dais, I'm very glad to be here. It's always difficult to come and give a talk at SCRC on structural engineering. You are the top people in the country in structural engineering. So what can somebody tell you? But I have to do something. So I tried to look back on why research is done. And all three directors very aptly talked about the fact that translational research is important. So I thought I'll look at what translational research can be done in the academic sector, how long it takes and why do we do it, and look at some success stories in the Indian context. So I'm looking at technology implementation as a reason for doing research. It need not be always the reason, but could be one of the reasons, and I think it's a key impact of research which could lead to translational research that the directors have talked about. So these are examples of the IIT Madras approach. Certainly is not just mine. A big group of colleagues, amazing people who I've been able to work with over the few decades. So why do research? All of us are researchers here, mostly in the audience, and we should think, why do we do research? Research could be for lots of things, just for discovery, personal satisfaction, papers, career progression, and so on. But each of us should have a goal of why do we do research. And this, I think, is very important. I tell my students, and I even question myself, why am I doing what I'm doing? So I think it's very, very important. There is no single right answer. There are many, many ways that each of us can look at it, but I strongly believe that each of us should have a reason why we do research to keep the motivation. So this is not just my question. Last year, Dr. D.Y. Chandrachud, Chief Justice of the Supreme Court of India, visited IIT Madras, and he asked us a couple of questions. One is, what are the values your technology represents? What is the outcome? Other than monetary outcome, what is that which is giving up? What you're giving based on your research? How does it further anything? How does it improve human and societal values? How is your technology changing everything? We cannot say technology does not change. It does. Just look at smartphones, how it has changed, how we communicate, how we learn, how we talk to each other. So this is something that is amazing. So what are the values our research is giving? Secondly, what are the affordances? That is, what are we changing due to technology? Dr. Anandvalli showed different technologies which have come out from your labs. How is this changing? For example, toilets, how are they changing? What are the things we can do to change things? So every technology has affordances. Everything changes human behavior. How are we changing it positively? Can we think about it as we do our research? So these are important things that I think are valid questions, and we have to think of answers. So what I recently did is an online poll. I did it in the context of RILEM. As was said, I was until recently the president of RILEM. And we asked certain questions. And these are things you can ask yourself now. Maybe later on you can send me your answers. But what has been the impact of your research? We saw the impact of research of the labs. But as individuals, what has been the impact of your research? And these are some answers of the polls. Some people said good quality papers. Some people say my career is advanced. A lot of people said advancement of scientific technology, scientific knowledge, because we learn more, we spread this knowledge, we disseminate. So this is very good. Then some people said advancement of construction technology, because this is the sector, we have to help the sector, and so on. So there always has to be some reason why we are doing it. And again, as I said, there is no wrong or right, but we must have some reason, some assessment. We should look back and say, what has been my impact? I've been working all these years. What has been my impact? And we also ask, what should be the future impact? We look back and we also have to look forward. So what is the future impact? So again, this is a question each of us should ask ourselves, especially young people. What am I looking forward to? What should be the impact of what I'm doing? Where am I going with all this? So again, a lot of people said high citations, they want good papers, continued career progression. Then some people said major contribution to improve construction technology, contribution to scientific advancements. So if there is a plan, then we will know where we are going. We also asked, why have you been so successful? What do you attribute it? A lot of people said, it's my scientific preparation, where I am. So it's very important how you prepare yourself for doing research, your organization support, collaboration became very, very important. This is something that has come out very well also in the talks of the directors. You have to collaborate. Professor Parida listed different entities which had to be involved. So this is something which is changing in the world today. When I was a student, it was very important. You were first author, you did the work, and you proved that you could do all the work yourself. Now it's not the case. It is very evident that one person cannot do everything. And as a group, we can succeed tremendously. So collaborations with whoever. Here, obviously, you have a great institution with a lot of people you can collaborate, sister institutions and so on. And we are neighbors, IIT Madras, so it'll be glad to have more collaboration with us also. We also asked, what are problems you've had? So everybody, each researcher can list a lot of problems, right? Why am I not doing amazingly? Why am I not getting the Nobel Prize? So there must be some reason. So we asked them, what have been your biggest barriers? Interestingly, a lot of people complain there's not enough funding. Yeah, this I think all researchers say. So if you also think that, don't worry, you're not alone, but still you have to do research. Yeah, you cannot say I don't have money, so I cannot do it. So inadequacy of funding, some bureaucracy, but I think in these institutions which are represented here, there will not be any bureaucracy. So things can be difficult. We know it is difficult, but still we have to move on. And we do move on. So I'll give you some stories. Like when you become old, you can tell stories and people listen to you. And you have to listen to me because Dr. Anandvalli called me here. So I'll tell you 3 stories from IIT Madras point of view, my point of view, and how things have developed since I started working, we started working on 3 aspects: fiber reinforced concrete, early age response of concrete, and mixtures with unconventional components. SCRC has done a lot of work on this in all these aspects, other labs also for many, many years, probably even earlier that is. But I'll focus on what we think we have achieved and translated, taken to the site. So in terms of fiber reinforced concrete, we worked a lot on slabs on grade. I'm very happy that Professor Amlan Sen Gupta is in the audience, because when we wanted to design slabs on grade, I went to him and he said, structural engineers don't deal with slabs on grade. He said, you should talk to the geotechnical people. I went to the geotechnical people and they said, we don't deal with concrete. We deal with only rock and soil. So I was wondering who really designs slabs on grade. And then I saw the contractor just says, take 8 mm bars, put 20 mm spacing and two layers, and that's it. And I wondered, is that the way we should be designing? No? And we started working on it, and we found fiber reinforced concrete is very interesting material that can solve a lot of problems in this. And for this, you needed labs to test, you need standards, nothing was there. So we started working on testing procedures. Several people from SCRC collaborated. We wanted to look at what is closed loop testing. How do you test? How do you get the post-peak behavior? The failure doesn't happen at the peak, but much after. How do we do all this? And so a lot of things we started looking at. So it's a little bit of timeline. Our interest in FRC started in about 2005. We started looking at what is needed in the country. Then we did our first road. You've also done a lot of experimental roads here, I know. So we did our first fiber reinforced concrete road in 2007. You can come and visit. 2008, we had a conference. 2009, we started a closed loop testing facility. Then there was a national committee by ICI. Then our first Indian standard came out in 2020. So you can see the timeline is long. If young people are here who think, how long will I take to get a standard? Minimum 10 years. Don't expect people to immediately recognize your research and say, you're doing great stuff, tomorrow you will get a standard. No, you'll have to wait for a long time. We, in last year, got approval for testing and design of SFRC tunnel segments. So now, after all this, I can say that in India we have at least 30 labs. It is not only IIT Madras. We have 30 labs who can test fiber reinforced concrete. We have 500 kilometers with fiber reinforced shotcrete. We have 19 million square meters of slabs on grade. Imagine in the early 2000s, it was just arbitrary construction. But now we do it systematically in our country. It has taken time, but we have warehouses, we have roads, we have basements, and the demand in 2024 is expected to be 3 million square meters of slabs on grade. So it can happen. It happens. And there is science also there. Like we found that doing a tension test is very difficult. So can we do an inverse analysis, what we found? We take a beam, inverse analyze, and get the stress strain behavior. So there is science which can be put in. It's not just simply doing something. There can be a background. You can get papers out of it and so on. But you have to know where you're going, and you have to be there for the long run. We worked on fatigue. Professor Parida will appreciate that there was not much research on cracked fiber reinforced concrete. How does cracked fiber reinforced concrete behave in fatigue? So we had to do these tests, and we showed that putting a little bit of fibers helps a lot in increasing the fatigue life. So we got confidence, and we started doing more and more on pavements also, other than just warehouse flooring and so on. We started looking at how cracked fiber reinforced concrete behaves. What happens after the crack? We are doing creep tests showing how the crack opens over a long period of time. Because we are not only interested in the initial cracking, we want to know if the crack continues to open or not. So we are doing tests in our lab where we have loaded specimens which we can monitor over a long period of time and see how these cracks open. Because as you know very well, durability, serviceability depends on crack width. Then we went on to structural design of slabs and pavements. We made a software that people can use. So this really we feel is taking things to the field, the translation from the lab to the field with simple equations, simple ways to design the slabs and pavements. So I think I have satisfied my colleague Professor Amlan Sen Gupta's query on who should design, and this is where it started many years back when I joined IIT Madras, and we have done things, for example, the airport luggage trolley ramps were designed by us and so on. And what I think is the next big challenge we should do is tunnel segments. Tunnel segments are right now done in a very tedious way. When the TBM is more, I'm glad that now we have more tunnel boring machines. It's not manual excavation. It is not just excavation, but the very sophisticated way of using a TBM, which combines the operation of excavation and construction and completion of the whole tunnel. There are many tunnels which are happening. Until now, all our consultants are from abroad. We need people to get confidence to have this know-how developed. We are starting to. We were very glad that last year the railway authorities approached us and said, can you check? Can you tell us if fiber reinforced concrete can be used? So we started looking at the design. We have completed the design for the tunnel segments with fiber reinforced concrete. We are talking to different authorities to see if we can do a trial section, and possibly soon we will have a trial section done. And why we are doing it? The demand is about 1,500 kilometers in the next 5 years alone. There is a demand in our country of 1,500 kilometers. If we can make construction faster, we will be doing the country a big service. So let me move on to early age response. Again, a lot of work has been done in SCRC and other labs. I'll tell you what some of the things that we've been able to achieve in the areas of flow, increasing flow, controlling flow of fresh concrete, segregation resistance, early age cracking, leading on to say 3D printing. First of all, we had to demystify certain things because the superplasticizer was thought of as a magic product. Some company will come, give you something, and then it will work or not work. And we found out it's not so complicated. It need not be a black box. We can start learning, we can start checking how superplasticizers behave. We started off from there. Then rheology, plastic shrinkage cracking. All of us, I'm sure, have heard contractors complaining that as soon as they pour the concrete, there is cracking. In our country, with the heat, the temperature, most of the regions, you will have this. How do we mitigate? So we started looking at this also. The thermal induced cracking, we started doing pilot projects. I'll show you a little bit. So again, timeline, we started in 2000. At the time when we started in 2000, you almost specified superplasticizer by brand. Famous things, they'll say Nitobond. They'll say, you ask the contractor, what did you do? He'll say, I put Nitobond. Why, what, nobody knows. But nothing against Nitobond, but it was going by brand rather than why we are doing it. Then we started working on self-compacting concrete. SCRC did great work on SCRC. I think you did a lot of work on piles. I remember work done here and many, many other things. And we started bringing out guidelines for cement superplasticizer compatibility. Construction started slowly. 2007, I remember the first residential construction with SCRC, with the SCC. And 2013, between SCRC and IIT, we have the research park. In 2013, we could do a large building with SCC. So it took about 5-6 years to gain that confidence. And we could do our own building and we could tell people, look, this is not something strange, you can come and see it. 3D printing was initiated in 2017. My colleagues Koshi Varghese and Manu Santanam push it. And we also started looking at grouting. All grouts were imported. For pre-stressing ducts, all grouts today are almost imported. So we started to see if we can make our own grout. We patented a grout which is there in the market. 2021, we had constructed a 3D printed house on campus. 2023, we collaborated with a 3D printed post office that even the Honorable Prime Minister tweeted. So this is something to showcase that India is capable of doing these things, that we can do cutting edge technology. We can lead, not only follow. So there is a rational approach. We can understand. We have been working on it. There is more and more use, more and more progressive use that we have to look at. So as I said, superplasticizers, we did a lot of work on superplasticizers to show how temperature can affect, how the different materials and different products can differ with a simple test called the marsh cone test. It costs no more than 30,000 rupees. And you can have reasonable results. You don't need very sophisticated rheometers, but on the site, this can be done. Similarly, plastic shrinkage cracking, we saw that materials, blended cements will cause more plastic shrinkage cracking. You have to mitigate. You can easily mitigate by putting 1 kilogram of polypropylene fiber. It's not something to dread or think that this we cannot use. We can, and this can be shown, and this can be done. With self-compacting concrete, as I said, we started off in 2007. Small building, small structure, but this led to larger structures. We got confidence and we've done the whole research park. You can visit walking distance from here, 1 lakh square meters, 5,500 cubic meters of SCC was used. And it has at that time the largest form finish surface in India, where we did not plaster. We saved material. If you think sustainability, let us not plaster anymore. Why should we plaster our ceilings? Why can't we leave the plastered concrete surface as it is? So these are issues that we can slowly push and get there. 3D printing, as I said, we did a house on IIT Madras campus 2021. Again, you can visit. There is a post office in Bangalore which is 3D printed, and this was completed in 45 days. The reason for 3D printing was this. Normally it would take 6 months. They wanted something fast. So 45 days was what was given and it was done. We also had the chance or the luck to compare with the traditional building. At about the same time, they were building 2 post offices. One was given to us for 3D printing, one was conventional. So we could actually compare the cost. We could compare the schedule. We saw how from 6 months, it becomes 1.5 months. Construction wastage was much less, little bit higher carbon footprint. We'll have to work on that, but really the cost and the time can be factors. We can promote this. The last story I want to tell is about unconventional components like fly ash slag, which are not unconventional anymore. But when we started, even CPWD had not. I think SCRC was instrumental in making this change that fly ash could be used in public construction. It took a lot of time, and we are now progressing in using recycled material, recycled concrete. I'm glad that my colleague Surinder Singh is here. He's leading the initiative. We did a lot of work on limestone calcined clay cement, which is now a standard. When we started, it was not there. So a lot of things have been done. We started demonstration projects. We started doing roads. We've done a small building on exposed to chloride environment, tetrapods in Tuticorin. And why? It brings down the carbon footprint by 30%. Compared to ordinary Portland cement that we think is what should be done, if you replace with blended cement, the carbon footprint goes down. In all these bars you see, it's going down. So that means without sacrificing strength, without sacrificing workability, improving durability, I get lower carbon footprint. So why not? Why can't we do it? We can save clinker for our country. We can save limestone for our country. So we should be continuing to do this. Now, how do we choose a sustainable concrete? Everybody talks about sustainability. So we try to come up with some numbers. We like some numbers. We like to choose some ways to do it. So we came up with two indices. One is called energy intensity, which is the energy required for making concrete divided by the strength. So we keep the mechanical aspect in mind. We also look at the energy, the cost in mind. The other index, we called it an apathy index. What is apathy? When you don't care. At the site, you don't care about durability. I don't like to say this, but this is the truth. The contractor, even structural designers don't care about durability. Nobody cares about carbon footprint at the site. So this we have to reduce. We have to limit this. We have to eliminate this. So that's why we called it the apathy index. So the idea is you plot for all the concretes you can use at the site. All your choices, you make this simple plot. On the x-axis, you put the energy intensity index. On the y-axis, you put the apathy index. What you want is something in the lower column. Okay? As low as possible. Out of all these choices, which is my best thing? And you can easily choose. Without sacrificing, you will not lose on cost. You will improve durability often. That's why it's there. So this is not just talk. We actually did it. So in Kerala, they were, one of my colleagues, Radhakrishna Pillai, is very good at convincing people. So he went to Kerala and convinced them to give him one bridge span. So this is a bridge. You can go and see, Valia Legal. And it has 3 spans, 2 spans conventional concrete. The middle span is when he got in and he bugged them so much that he was allowed to change the mix. And if you look at the plot, this is the same plot what I showed you earlier. X-axis has energy intensity, y-axis has apathy index. The top 2 dots are the other 2 spans, the conventional concrete. We wanted to now bring it down. So what did we do? We changed the concrete 50% GGBS. Strength is the same. It is M40. But we also said D50. What is D50? Durability. Can we bring in a durability parameter just like you have your strength parameter? Can we also? So he calls this MXDY. So M40 D50. What does the 50 stand for? It is the surface resistivity that we need to avoid corrosion. Consequence, life expectation increased from 30 years to 125 years when calculated based on chloride ingress. CO2 savings, 230 tons just for one span of one bridge. So we can change, we can influence things. There were talks, there were presentations about the Ram Temple also. So we happened to be involved along with CBRI in the foundation. As you know, the life expected was 1,000 years. So that means no reinforcement. We have to visualize all sorts of attacks that can happen. So finally it was decided that you had to dig a pit for the temple to be constructed, 12 meters. Again, Surinder Singh, who is here, was in charge of the roller-compacted concrete. Low strength was done with lot of fly ash, low amount of cement, and the building is, the temple has come up on top of this foundation, raft of self-compacting concrete, all done reasonably well. So, to conclude, I strongly believe that we should think of values, we should think of translation, we should think of technology implementation as early as possible in our research. We should know what values we can go for. For this, we have to understand the concerns of the industry. Especially academics like me cannot sit in my office and imagine that I'm going to change the industry if I've never gone to a construction site. I have to, you have to, if you want to make an impact. We cannot just sit, read books and think that we will change. We have to do it. We have to be willing to collaborate at the construction site. It is very difficult. It is not easy. But if we want to change things, if we want value for our work, we should do it. We should go to construction sites. Young students, young engineers should go to the construction site, understand the problems there. They're very different from what we read in the books and what your teachers tell you. We have to get stamina. Research is there for the long run. Like I told you, all the things that we have done has taken us about 10, 15 years to get it done. So that means you need stamina. It's a marathon. It's not a sprint. It's a marathon. You have to be in there for long run. If you want to get standards done, if you want to get pilot projects done, if you want industry to believe what you are doing, you're there for the long run. We have to convince professionals, especially academics like me, that we are not just in ivory towers. We can come down and we can talk to them, we can talk their language. This is also very, very important. And we have to realize that academia industry cooperation is very much, especially in our country. There was a big divide between academics and industry, the real world. We have to bridge this and we have to work together, otherwise what we do is useless. As far as the construction sector improvement is concerned. Obviously, you can do a lot of basic science that I will never be opposed to that. But if you want construction technology to change, construction sector to change, you have to go there. You cannot be away from industry. For this, we've started a new center called TLC2, Technologies for Low Carbon and Lean Construction. Many people are involved and we are joining with industry and trying to work on this as much as possible. So we organize a workshop every year where we invite people from abroad, industry, young people to talk about it so that we can promote this and make sure that there is this translation that I talked about. So with that, I'll thank you. Thank you very much. I'll stop here. Pleasure to be here and talk to all of you.
Thank you, sir. Thank you for sharing your experiences on very diverse projects in construction industry and also highlighting some of the challenges which our country is facing right now. Thank you so much. I now request Dr. Saptarishi Sasmal, Chief Scientist, to introduce our guest of honors.
So the dignitaries on the dais and the dignitaries of the dais and the senior colleagues and my friends, a very good morning to all of you. It is my pleasant duty to actually introduce Professor Prasad Rao Rangaraju. So Dr. Prasad Rao Rangaraju is the professor at the Glenn Department of Civil Engineering in the Clemson University. He received his PhD from Purdue University and the MS from the Iowa State University, and bachelor degree he has got from the JNTU Hyderabad, India in civil engineering. He is a registered professional engineer and a member of the ASC and the ACI and the Transportation Research Board, International Society of the Concrete Pavement and the ASTM. So he also serves as the editorial board member of the ASTM Journal of the Advances in the Civil Engineering Materials, and also as an associate editor of the ASC Journal of Materials in Civil Engineering. His research interests include cement, concrete, aggregates, and the supplementary materials, microscopy and the petrography of the cement-based composite, repair materials, durability of the cementitious systems, and also on the concrete pavements in respect of the design, construction, and rehabilitation. Dr. Rangaraju has established a sustainable material research and the technology called SMART Center at Clemson University to develop and promote technologies related to the green construction material and practices. So that with this short brief introduction, I would like to request Professor Rangaraju to give us that wisdom. Yeah, please. Thank you.
Well, thank you for that introduction, and thank you for inviting me to talk at this event to Dr. Anand Valli and all the other dignitaries here. Really appreciate this opportunity. I did not come prepared with a lot of slides or anything. I won't take too much of your time, but I want to say a few words about what we are here, on the importance of the activities that we do as civil engineers, research and industry practice, and how relevant and important it is for the modern society, right? Perhaps of all engineering professions, civil engineering is one that touches every aspect of human life. And what we do is extremely important for the well-being of our citizens, of the country, the economic growth. And this is true whether it is India or elsewhere. Civil engineering is very vital for upliftment as well as progress of the society. Dr. Ravindra Gettu here has very eloquently talked about a lot of different aspects that are important from academic perspective as well as from industry perspective. We perhaps share a lot in common in terms of our subject matter expertise. So I won't elaborate on all of those, but I do want to talk a little bit about, especially where I come from, the United States, what is happening there in terms of these aspects. And we've heard some of the terms here as well, that the sustainable and resilient infrastructure is extremely important, especially in this day and age where we realize and recognize the impacts of climate change. There are a lot of environmental issues that are starting to impact how our infrastructure has to be constructed, how it performs, its durability, and so on and so forth. And it is in that regard, I think civil engineers, particularly the area that I represent in the construction materials and that aspect is really important. There's a lot of changes that are happening at the present time in reducing the carbon footprint of materials. Our cements that we are used to, ordinary Portland cements, for longest of the time are now transitioning to Portland limestone cements or LC3 cements here in this country. Alternate supplementary cementitious materials that are coming on board, how they are going to impact the material performance, both mechanically and from a durability standpoint over the long run. These are some of the critical issues that we need to focus. Interestingly, I've heard speakers here talk about using fly ash in concrete and slag in concrete. Obviously, those have been resources that have been available to us to use as cement replacement materials for longest of the time. However, because of the policies that are being put in place, at least in the United States, our energy production in the US, which has historically been dependent on coal-based power production, and obviously that results in coal-generated ashes, that has transitioned away. Now, a lot of US energy production is moving away from coal. Thermal plants are going away. We've replaced at the present time with gas-fired power plants. There is more renaissance or sort of nuclear power is sort of on the rise. There's a lot of renewable energy, wind energy, solar. All of those essentially are creating a dearth of fly ash. We no longer are producing fly ash. in the US as much as we used to. And the concrete industry was so used to using fly ash in concrete, all of a sudden is facing the prospect of there is no fly ash. Slag, we really don't produce much steel in the US. Much of it is imported into the US, and therefore we don't have slag. Slag has to come from outside. So what else do we use if we don't have fly ash and slag in concrete? So we are on a mission right now to explore alternate materials that have never been considered before seriously. And that raises a whole issue of what is the performance of these materials. So for example, we saw here the waste to wealth program that you all talked about, and agricultural waste. That is something we are also seriously looking at. I personally am involved in a lot of research in recycling glass waste in the US. We produce a tremendous amount of glass waste in the US in the form of container glass, plate glass, all sorts of glass. And right now, much of it is landfilled, partly because recycling it is challenging. So we have actually developed a new standard based on some of the research that I've done on developing ground glass porcelains as a replacement for cement. And we can actually even make a concrete with zero cement, completely with alkali activated systems, some of the geopolymer systems that were referred to. So we are treading in a new direction here in terms of our needs, in terms of materials, in terms of structural designs. And I think we have a lot of challenges ahead that we need to work collectively. And again, the important point that was made here is translational research. It is not something sitting in a lab and doing something and ending up in a referee journal paper or something, but translating this to practicality, in bringing it into the field is extremely important. And I think the initiatives that that are being pursued here and being showcased, what I saw outside in the posters, is very promising. So with that, thank you for this opportunity.
Thank you, sir. Thank you for briefing us a different perspective, like from US or from a US, like what work has been done and what should be done here also. Thank you for highlighting those points. Thank you, sir. I once again request Dr. Saptarishi Sasmal to introduce our chief guest, a guest of honor of today's event, Professor Hemant Dolai from the University of Melbourne, Australia.
So it is also my pleasant duty to introduce our guest of honor, Dr. Dolai. So the Dr. Hemant Dolai is currently an associate professor at University of Melbourne, specializing in project and construction management. He is also having more than 6 years of industrial experience in the multinational company. And Dr. Dolai has consistently been publishing the research papers in the journal with the highest repute. And he has more than 200 research papers in the reputed peer-reviewed journals and the conferences in the area of the construction management and the engineering internationally. So Dr. Dolai is also the founding chair of the International Conference of the Smart Village and the Rural Development. And in 2012, Dr. Dolai's outstanding contribution into the research and teaching has been recognized by honoring by the nationally competitive the Infinite Value Award in Research and the teaching administered by the Australian Institute of the Quality Surveyors. And currently, Dr. Dolai serves as the associate editor, guest editor, and also the international editorial board of quite a few leading international journals. So with this very brief, so I would like to request Professor Dolai to come and have his address. Yeah.
Thank you. This is my real pleasure to be standing here and talking to so many scientists of this country. I don't think that I'm qualified enough to be able to really give any advice to anyone, really. But this is my now the call is made that I have to come and speak a few words. And again, this is a very short notice. I even didn't know that what is happening today. I was just called in, and Professor Ravindra Getu is very good at giving me the surprises. And yesterday, Dr. Ananda Vali, madam, you called me quite a few times, but never tell me exactly what to do. So it is very interesting. But again, when I was sitting here, I came a bit late, but I was just picking up a few keywords here and there. And those keywords have actually given me some ideas to talk about, if I may. So a couple of things. When Madam was talking, and I just picked up her few keywords, she talked about climate change as a keyword. She talked about SDGs, the UN's Sustainable Development Goals. She talks about infrastructure, and she talks about the society. Then I picked up another three big assets that are coming out through this particular program. Is the science, everybody is a scientist here, and the structures, everybody is a structural gurus. They all know about structures very, very well. And then finally, the society. Society again came up second time. So three S's. So structures, the science, and society. Now I want to pick up the point on society. So what we need to do in India, what we need to do in Chennai, what we need to do in this part of the world is quite defined by the society that we wanted to serve. If we wanted to do something in Australia, if you wanted to do something in the US, in a very particular context, very particular place, it is about the society that we are going to serve. So US's problem or US's solution cannot be put into India. Indian problem cannot be put into Australia. It is very, very unique. So when you talk about society, the social value that comes into play. So the people, and if you talk about the social value, where do you start? What we value as our best value in our perception. It is about our perception really. If I go through a 6-lane highway and 100 kilometer speed, my value to that particular road is very high perhaps because I have a fancy car, I can drive at 100 kilometer speed, and I can basically enjoy my drive. That is my best value of that particular project. But if you look at somebody sitting by the side and ask that particular person about the value of that particular road, it is next to none. Because that particular person doesn't have a car, that particular person even doesn't know how to drive that car. So it is very, very important that we drive the values of the project from the society that we are serving in. With that in mind, I just wanted to throw a challenge here. Talking about India. What is India today? Yes, India wants to be global today, maybe fourth or third position. We like to be top in the world. That's all fine. But at what cost? Do you ever care about what India should be, where India should go? It is more about what India should be in long run. So Indians will always be Indians. India will be always India. Now, how can we really build our India to be a place where we do not lose our culture, we do not lose our value, we do not lose our heritage, rather we build on those. If you look at today India, it's a classic test bed. Nowhere in the world you can find a place like India. The reason is that India has about 17 to 18% world's population. That is number one. That is what India is defined. India is hosting 17% people of the world. That's one very unique character. Secondly, India has got good 80% people who are rural. 20% people there in the cities. Thirdly, India has got 750,000 villages. 7 lakhs villages in India. Every single village is unique. I'm talking about my own state in Assam, from northeastern part of India. Many of you may not have seen Assam. Assam looks like many people think that Assam is a jungle. But Assam is surrounded by 7 other beautiful states. It's 8 state sister states kind of geography with more than 300 tribes lives in Assam. 300 unofficial tribes, officially about 130 tribes. So if you ask any of those people about what they eat, what they do, and how they value their own shelter, own house, you see a big disparity there. Their food is different. Their perception of the space in the house is different. If you go from Guwahati to Dibrugarh all the way, you can see many of the poor villages on the sides. But at a glance, you see those houses are quite similar, and many times you might think that there are poor people living by those poor villages. But you stop by and go to one of those houses and see and ask them what is the meaning of their house. They will tell you precisely that this is the space in our house is good for the elders. This is the space for the house, good for the youngers. The right side is the kitchen. Left side is the veranda where our elderly people sit, and the middle part is our secret place where we pray. So every single space within that house of every single tribe is defined by their heritage, by their values, by their culture. Now we are talking about Prime Minister's Yuvas Yojana, housing for all, build the brick and mortar houses and impose to everybody. I can show you some of the houses built in Assam. Those houses, even the cattle do not live in there. That is the science that we are using to unjustify our society. That's not right. So I'm not criticizing the program. I'm not criticizing the science or the scientists, but I'm criticizing that the science and the values that we all create is not matching the societal need. That is our biggest challenge that we need to have. And coming back to the point of India being India, I think those 750,000 villages have to be kept as villages, so that these villages will be our definition, our uniqueness, and that is our point of exhibition. The rest of the world will come. In next 100 years or so, nowhere in the world you can get a village like what we get the village in India today. These villages have to be retained, the villages have to be highlighted, these villages have to be in the world's tourist map. Everybody needs to, they will all come. Money is not a shortage in this world. People will come, bring the economy, and finally those villages will be flourished by their village economy, provided we maintain that character of those villages the way it should be. It's very, very important. Now, the last point I want to make it here, because I'm a civil engineer. I was a scientist like you perhaps as well in some point in time. I was very much interested in concrete and structures and water resources and coastal engineering. I did many of those things in my life. I did my master's in coastal engineering. But over last 6 years, about almost 6 years or so, I have been working on quite different areas, which is the Smart Villages Research Program. And I don't know whether I am qualified, but I am passionate. And my passion grows, my actually emotion grows about that particular area, because I wanted to see that these village people get their best justice by our science. We wanted to really maintain their heritage. We don't want to evade their heritage by imposing the science on them. It's very, very important. So I'm an Indian, and that is where my heritage is, and that is where I really come back to India. My heart and soul is always in India. Physically, I am in Australia. Then when we talk about that those Indian, 750,000 villages, in Assam alone, where I came from, 26,000 villages are there, and every single village has got the unique entity, but now they have been very quickly destroyed by the science. Now, if we talk about the global problem, the climate change and the global warming and all these changes that we can see around the world, we have got only one greenhouse. And I tell my own kids that we human are very, very ruthless. A tiger would not destroy the forest because that forest gives the shelter to a tiger. The fishes would not bring the poison to their own pond because fishes have to live in these ponds. But we human race, we live in one single pond, which is the greenhouse. We poison day in, day out. And we don't care at what point in time this poison becomes such that we become inhabited. Think about our cars, think about our all the industries that we are emitting day in, day out, but we breathe those air day in, day out. But do we ever care about it? Care? Perhaps we don't, because we have not got to a point of no return yet. We are still breathing here. We are surviving because this air is good enough to be able to breathe. But one day, this air is not going to be good enough for us because we are polluting day in, day out. Now, there was a recent article that I just read that 50% people in this world has got the plastic in their bloodstream. We do have the plastic in our bloodstream. And plastic is the one creating the problems of the newborn babies in terms of their, the various issues in their life, including the autism and, neurological underdevelopment conditions. So if 50% people are having the highest level of plastic in their bodies today, that is something that we need to be worried about, where it is coming from, and what we are going to leave to the rest of the world if we just do not care as a scientific community today. It's very, very important. And also I read recently another very interesting article from a cardiologist from India. He says that in the book, anatomy book, their heart is shown as pink heart. But today, that cardiologist has never seen in the laboratory any pink hearts. All the heart of the human body that he or he is looking at in his practice is all black hearts. So the pink color of the heart is gone. That is only in the book today. So that means we are already creating enough damage to the human race by our own actions. So then talk about the science and our innovations. We got to really be very, very mindful. And the very last message I like to give, that whole world talking about the greenhouse, I think that this world has got yet a 40% people still in rural. Talk about Africa. I just met with one of the scientists from Africa recently. There are some places in Africa, very dense, 600 million plus people lives there without any proper shelters and proper infrastructure. Imagine that those 600 million people will come out and try to absorb the similar kind of resources like us in the cities that we are doing it today. What will happen to this world? I'm not saying that it is an African problem, but there are densely populated places in this world that do not have enough resources, but they are human beings. They have got similar ideas as us. We all need the similar kind of resources. My family have got 4 people in Australia, massive mansion that I consume as my house. I've got 3 cars. I am a sophisticated man. With my resources that whatever I can assume, I can just assuming it. I'm absorbing it. But at the cost of who? Cost of maybe 1,000 more people who are back in Assam in the rural areas. There was a statistics published by IEA, International Energy Agency. One flight we take from Singapore to New York is equivalent to 1,000 African villages. So the amount of damage we inflict to the world, to the greenhouse by one flight from Singapore to New York is equivalent to 1,000 African villagers. If you put a scale, 1,000 here, 1 person is here with this sophisticated life. That's the balance we have got today. And if that balance we get it wrong, imagine what can happen there. So I think world has got still 40% people in rural. Those rural people should not be competing against the 60% people. There's no competition here. There is a shared vision, shared values. And that is what my contemplation is. I think our current literature says that rural has to be urban. There is the urban-rural divide. And that gap has to be reduced so that the 40% people who are in the rural sectors, we look down to them. They have to be brought to the mainstream to be urbanized. That is the wrong literature. So I am contemplating that literature has to be stopped. We have to define a new literature here that is the urban-rural share. So urban has got 60% people in this world. Megacities people have got the purposes. They have to run the economy. They have to run the countries. That's okay. But the remaining 40% people who are in the rural, they have got a purpose too. They are the one who is producing food for us. They are the one who is supporting our 60% people's urban lifestyle. So that balance have to be struck, and that balance has to be contained in a way that we have got a harmonized planet. Thank you very much.
Thank you, sir. Thank you for sharing your experiences and also sharing a lot of examples and also emphasizing on one most important point, which is societal problems should be the driving force for science and innovation. Thank you, sir. To express heartfelt gratitude for the presence of our esteemed dignitaries today for spending their valuable time with us, I request our director to present a memento to all our esteemed dignitaries. I once again request our director, madam, to present a memento for 1 week, 1 theme program to all our esteemed dignitaries. Thank you, ma'am. I now request Dr. P. Harikrishna, Chief Scientist, to deliver the vote of thanks.
Good afternoon to one and all present here. It is my pleasure and privilege in proposing the vote of thanks on behalf of CSIR SCRC. I thank Professor Ravindra Gettu, IIT Madras, for immediately agreeing to be the chief guest for this event of 1 week, 1 theme of CIE theme and for giving his address. I thank Professor Prasadrav Rangaraju, Clemson University, and Professor Hemanta Dolai, the University of Melbourne, for agreeing to be the guests of honor for this event and also delivering their addresses. I thank Professor Pradeep Kumar, Director CSIR CBRI, and Professor Manoranjan Parida, Director CSIR CRRI, for presiding over this function and delivering their addresses. I thank our director, Dr. N. Anandvalli, for giving the welcome address and also for providing her guidance and encouragement in organizing this event. I thank Dr. Amar Prakash for delivering the introductory address of this event and also for his and also his team support in organizing the exhibits and posters. I thank Dr. Parivalal, Chief Scientist, Advisor Management, for introducing the chief guests of this event and also for his suggestions while carrying out various activities of this event. I thank Dr. Saptarshi Sasmal for introducing both the guests of honor on this occasion. I thank all our CSIR colleagues from CSIR CBRI, CSIR CRRI, CSIR CMERI, and CSIR AMPRI, along with the colleagues from our own CSIR SCRC for joining this event. I thank all the delegates from various government, public sector, private organizations for attending this event and making this event fruitful. I also thank all the respective government, public sector, private organizations for nominating these delegates to attend this event. I thank all the professors from institutes and universities and also the research scholars who also joined this event to make it more effective. I thank all the scientists in charges from various annexes of CSIR Madras Complex and its administrative heads for attending this event. I also express gratitude to all my colleagues from CSIR SCRC who are part of this organizing committee and various subcommittees along with co-opted members for their unconditional and unwavering efforts despite their existing commitments in organizing this event. For want of time, I could not mention all the names, but I will be thanking them in person. I would also like to thank various functional heads and the staff of Director Office, Advisor Management Office, SHRDD, BKMD, ICT, HRD, Works and Service, Horticulture, Electrical Section, Canteen, Guest House, AO, F&AO, and SNPO, Security, etc. for their support in organizing this event. Thanks are due to our colleagues who made various arrangements of the registration desk, all the dais arrangements, comparing, audio-visual, stalls, lunch, refreshments, vehicle provision, etc. If I miss in expressing my gratitude to anybody, it is not intended. I may be excused for it. I once again thank one and all who helped directly or indirectly in organizing this event. Thank you.
Thank you, sir. This brings us to the end of the inaugural session of 1 Week, 1 Theme. I now request all of you to please rise for National Anthem. Thank you all. The next section will be on technical presentations. We'll break for tea. Tea will be available in the dining hall and reconvene here for the technical session at 12:30. I once again welcome you all for the technical session. I invite the speakers of today's technical session, Dr. Saptarishi Sasmal, Dr. P. Harikrishna, Dr. Kishore Kulkarni, Shri J.K. Goyal, Dr. Subhatra Mondal, Dr. Rajiv Saxena, and Dr. Anup Kumar to adorn the dais. The first presentation will be on the topic Structural Health Monitoring and Life Extension by Dr. Saptarishi Sasmal. Sir.
So a very good afternoon to all of you. So it is my actually privilege that I want to share some of the works done and also where we are going forward as a part of the subvertical called the CIEs in the SHM, Structural Health Monitoring and Life Extension. So in this life extension and the SHM, there is having a CIE theme lab that all the labs are working together. So I will try to present the whole work as in the morning session also was telling that about the research done, from the research how the technology, methodology and the procedure have been made and how those things have been made is so useful to solve some of the industrial challenges. So since the time is very much restricted, I will go a little fast. And if you have any question, you can ask me also later. So basically, I don't have to re-emphasize the need and the relevance of the structural health monitoring because so it is a global challenge because the developing a new infrastructure, it is an indicator of any development of society, but it is also posing a challenge. How do you maintain and how do you ensure that there is no catastrophic failure is happening from this one? So in that, if you're really surprised to see that nowadays the analysis, design, detailing, implementation and all have become so advanced and so sophisticated, even then this type of things are happening. So that we have to really question, there will be having some point that after taking care of everything also, there needs to having some more check. So that check actually is called the health monitoring. So even after implementation, when the structure is in service due to the environment, due to loading and due to the other unforeseen condition, it will show some symptom and those symptoms have to be captured in time. It has to be analyzed properly and that we should take the action appropriately. So this is basically the so SHM because we have gone from this schedule based maintenance because nowadays between two schedule it can have so many things, so that from the schedule based maintenance to that you have to go to having that type of this so SHM. And if I have to just giving you that analogy, because like the doctor that gets the symptom, and here I will try to emphasize is that not getting the signal or the symptom is that important than to how do you interpret it, and after interpreting how do you taking the intervention measures. So these are the things that will be required as a part of the SHM engineer, right? So the structural health monitoring that could be told as one of the ideal example of getting the interdisciplinary approach. If you see the health monitoring, though it is having a word called structure, it is nothing to link with the structure alone. That you need the computer, need the sensors, need the signal processing, need the transfer of the data, storage of the data, all the things together, and also it's having a very advanced and the sophisticated FEM also have to be there. So all the different disciplines they come together and then they have to give the solution for that type of thing. So as it is required for the SHM and one of the subverticals of the CIE theme, and so that it is not bound, I will show some of the slides that the need and the requirement of the SHM has gone so far. So the contributions and the work done is not limited to only from the CIE theme, even from the non-CIE theme, those labs are also giving a significant contribution. If I tell in a nutshell, basically that what it is happening in the significant R&D contribution, because so that I will maneuver from the R&D to the technology to the industrial challenges. If you see the different R&D contribution, because the dynamic nonlinearities to identify the breathing crack, this is one of the significant contributions have been already come out. And this advanced entity, so nowadays no longer this having ultrasonic and the UVP are found to be sufficient. That has been shifted to the nonlinear ultrasonics, and also the high frequency wave propagation for this corrosion, this acoustic emission based the passive measurement techniques, lamp wave based techniques for having a long stretch pipelines problem, and also this having a so monitoring the inaccessible areas by using the UPV, all those things that will be required. And that if you see that there is having a one hindrance is there, most of the time the SHM is linked to the sensors, and most of the sensors are being imported. So there is having a very very well coordinated project has started by the sponsored by MeitY Ministry of Electronics, and having a 5 years project, and to develop the indigenous sensors. I think it will be actually changing the paradigm for the whole thing. So in brief, that I will take about the dynamic nonlinearities. If you can really see, and if you see the phase planes, you can be able to detect the very fine crack before the crack, whatever you are talking about, the load drop type of crack is happening. So it has been shown that also it having a 4.5 meter long structures that could show the things that having that type of breathing crack. In the similar way that we have shown that if the ultrasonic, it will show you a damage in a long later than if you use the nonlinear ultrasonic. Even the onset of the crack, I think any civil engineering, the onset of the crack will be much more important than what it is appearing. So this has been shown, and as a CIE theme that we have already developed, they're having this ultrasonic tomographic, this in-house coding, so that it can show you that how this type of damage mapping it can be done. And regarding the mechanical loading, similarly having environmental loading also is a big concern. So when this corrosion is happening, most of the time that we see the color change on the top of the surface, or when you are seeing the crack on the surface, I think it is too late, because under the corrosion, when the crack comes into the top, already inside a significant amount of the damage has happened. So what we have shown that even that when that having that corrosion starts so around the reinforcement, and because of the volumetric change, the micro crack happens. If you use a technique like the nonlinear so ultrasonic, or by using the acoustic emission, or having having two things together, actually I will not be able to present, but it was giving a very interesting idea that if you use the machine learning and take the nonlinear ultrasonic and the acoustic emission, even at the 1/3 of the time when you could have got the real signal of the corrosion, so that you will be able to see. Right. Even that when that I think most of the people here are also working in concrete, the concrete setting and the hardening is the one of the issues. Even that we can see that having acoustic emission, the frequency shift, it could be used for actually indicating that how much the hardening of this concrete has happened. And the team of the SHM is working on the having an active passive and also this contact non-contact based technique, because this contact non-contact based technique means if you use the non-contact techniques, that will be getting the surface information, but it is easy. If you use this contact based technique, it will be giving you the entire structural formulation, but it will be very complicated, because in the most of the structure you cannot approach to there. So the digital image correlation and the AE having a coupled technique has been developed. So not only to detect the damage, even having a fracture process zone also you can be able to calculate. And as I was mentioning, the long stretch pipeline problem, if you're having a lamp wave, at SERC having a state-of-the-art facility has been developed by using the laser Doppler vibrometer, and by using that non-contact, that you can excite the structure, and so that you can use the different algorithms have been developed as a CIE theme, and so which can tell you that where the exact crack is there. Also for this bridge monitoring, this wind vehicle that has been also developed, it is being sponsored by the DST. and the high-speed rail network, because that now we know that the India is poised to go for the high-speed rails, and most of the technologies are being imported. At ACRC already developed a project where the total material system and the technologies has been developed for the high speed. So also give you the requirement for developing a real-time continuous health monitoring, because you may not be able to afford any sort of catastrophe that will be out of this coming from the high-speed rail problem.
Dr. Sasmal, another 1 minute.
Yeah, okay. So this is by using this unmanned vehicle, and as Director Madam was talking about this Polavaram Dam project, but by using the acoustic emission, how you can check the health of a dam, and this has been done, and this is the one of the longest and having a 54-meter radial gate. It is the Asia's tallest gate that is there, so that has been done. And from the railway, I think that ACRC and CBRI and CRRI are working for the NHI railway, and especially for the railways. If you see that almost the India's the different parts are getting contributed by the team from the SHM. Basically, the structural performance, structural auditing, safety auditing, capacity augmentations are being done. And also that we are working on to develop some technology for using that longitudinal force mitigation. And so this work is happening, and this is the very recent one is in the Pamban Bridge. This has been actually covered by many press people, that having lift span has been already been installed and has been monitored by the SHM team. Now that research and that this type of interest, now that you have been developed from something technology, it is the innovative, the cement-based embedded technology. So where you can use for the real-time health monitoring without any extra power or that will be giving any sort of the adhesive problems. And this is the expansion joints are the major problem of the bridges. There is having an effort to develop a new and the innovative way to develop some system where the expansion joints can be omitted. And this is the indigenous development of the fiber optic sensors that can be used for the rail networks, safety of the structure. It has been very advanced stage. Actually, it has been already demonstrated in the Mangalore and also some other places of the railway. And this technology, as from the morning that is being talked, that all technologies, research and the R&D has to go to the market or to the society, because the NHIDCL has done the MOU so that we can make use of those technology to go to the market. And also, as I was telling that vertical 3 is being led by the ACRC, and this is the project that is being having a mighty and 2022 to 2007, because generally the government of India's project for 5 years is very rare. And here if you see that it has gone beyond the CIE theme because of the requirement that NAL, SIMFAR, and also that we have got this having a NML, CGCRI is there. And as a roadmap that we have done some technology that has been getting the challenge that has been made. Also that we are having a very ambitious plan, having a short term, mid term and the long term. And there is a plan as a CIE team that will be developing the full scale test bed. I think in India it is not there. And also in India there is no code, no guidelines, no specification that can be used for the SHM. So that will be also one of the major goals, so that will be taking forward. So these are the few of the clients. So that shows, this slide shows that the research is not between the boundary here. Now it has gone to the market, and that we are seeing how to improvise or how to use and to contribute more and more to the society. So with this, I would like to thank, and I would like to thank the director for giving me the opportunity for presenting the thing for the SHM. Thank you so much.
Thank you, sir. The next presentation will be on topic disaster mitigation for infrastructure by Dr. P. Harikrishna.
Good afternoon to one and all. This subvertical is on disaster mitigation for infrastructure. As we know, India is prone to various hazards as listed here. The listed ones are only a few, but there are many other hazards are also there. Here, India is prone to seismic cyclones and also landslides. Apart from this, floods we hear every now and then, every year event, even though these events are usually happen once in 50 years, once in 10 years, like that. But nowadays we hear floods happening every year, even sometimes within the same year, 2 times also. But here most of the work carried out by CSIR labs, that is SCRC, CBRI and CRRI, focused on these three hazards. Those aspects are highlighted in this presentation. Close to 76% of 7,500 kilometers prone to cyclones, and 19 states are prone to landslides. And 2030 guidelines are there, that Sendai framework for disaster risk reduction. They are emphasizing not just only societal and other aspects, but they are also emphasizing on the infrastructure. So they are telling to substantially reduce disaster damage to critical infrastructure. So for that, they are recommending that the existing codes of practices need to be revised, and also development of new codes of practice to be brought, and also to develop the new technologies so that the disaster damage can be reduced to the critical infrastructure. Not only Sendai framework, but also Global Future Council of Infrastructure and Sustainable Development Goals and Technology Vision. All these things emphasize the disaster and climate resilient buildings. So towards this goal, CSIR laboratories, SCRC, CBR and CRRI contributed to various natural disasters like earthquake. One is development of probabilistic seismic hazard map and seismic microgeation, and not only the testing R&D things, but directly to the end user, pseudodynamic test for nuclear power plants, retrofitting methodology for open ground story structures, that is already existing structures with car parking is there. They are all actually, if you assess their performance for any different earthquake criteria, they will be not passing. So for that, retrofitting methodologies are needed. So SCRC has come out with retrofitting methodologies which are easy to design and implement, and development of passive energy dissipators, which are very important in various structures to absorb the earthquake energy, and also real-time hybrid simulation of structures. These are very specialized things in industrial structures. And with respect to cyclones, ACRC has contributed to revised basic wind speed map, which is already implemented in NBC 2016 and IS 875 Part 3 2015. And ACRC has carried out a lot of field measurements during normal and cyclone wind times. Wind data was collected. From that, what was observed commonly is that during cyclone times, more turbulence intensity means more dynamics. And guidelines for non-engineered, semi-engineered housing came out. And recent past solar PV panels, ground-mounted structures, design wind loads. And a lot of research work is carried out on wind-sensitive structures like tall buildings, cooling towers, and low-rise structures with light roof systems. One of the key contribution to BIS codes is IS 15498, 15499 and IS 875 Part 3. So in this revised basic wind speed and importance factor for cyclonic region is our very important contributions to the BIS code. And with respect to earthquake, again, landslides, hazard zonation and vulnerability atlas, landslide early warning systems, these are developed by CBRI, and failure analysis and design of remediation works for landslide along highways, this is done by CRRI. Design guidelines for micropile reinforced debris slopes. All these things are basically to strengthen the slopes in the hilly regions so that landslides can be arrested. These things generally happen during monsoon season, and along with the floods and the landslides they happen. So all these technologies were brought out by CBRI and CRRI and already being implemented in field also. With respect to man-made disasters, blast, India is prone to various issues like terrorism. So these defense-related things also. Slurry-infiltrated fibrous concrete for blast-resistant design, where you can store the very sensitive items. Laser steel concrete composite for blast resistance. Igloo structures for explosive storage. Steel fiber reinforced cementous panels for ballistic impact resistance. All these things with respect to blast related. And to other industries, contributions are full-scale testing of pallet racks, RINL dynamic response measurements, NMDC, all these are field measurements actually. We have gone to the field and then provided the solutions to the industry. Wind tunnel investigations on RC chimney, which is very important, power plant structures. Most of them happen to be in coastal regions prone to cyclones, so wind tunnel investigations become mandatory. A lot of investigations were carried out. The last one is emergency retrieval system. This is transmission line towers. They generally collapse after very high wind event like cyclones and downbursts and thunderstorms. And immediately to restore it, these retrieval systems help to bring back the power supply within 2 to 3 days. Right now, it is that importing technology is there. It is very costly. So SCRC come out with indigenous technology, which is almost 50% of the imported technology, cost-wise. Society contributions, cyclone shelter design is provided by CRC. About 75 of these design are implemented by Orissa Red Cross Society. And since 1975 onwards, these shelters, more than 25 years, they are helping a lot of people who are living in low-lying areas during cyclones. And they also serve as either schools or community buildings during other times. The other things are that hospital buildings, floor isolations are very important for medical equipment. For that also active control systems and floor isolation systems are designed. And to the strategic sector, ISRO Sriharikota, SCRC done a lot of internal investigations for umbilical tower, lightning arresting towers, second vehicle assembly building group effects. All these things are done and already they are implemented. And other strategic sector is that hardened aircraft shelters. So they are defined for 2000 lb bombs. So design is provided to them. And these design technologies in such a way that it is customizable. If you come with a higher level of demand, like more than 2000 lb bomb also, a design can be provided. The other things done for nuclear power plant and other industrial structures is seismic qualification test using the shake table facility available at SCRC. Vibration testing of fuel tanks. These are drop tanks either in aircraft or in helicopter. All these tests we could provide the solution to the industry. And these are the recent technologies profiled, ready to give it to the technologies. Some of them are already transferred to the various industries and going to the field level also, which include the passive energy devices, magnetorological elastomers, dissipative fuse links. All these are for earthquake resistance. Laser steel concrete composite system and fiber reinforced impact resistance. All these are for blast resistance. Prefabricated steel foam concrete composites. These are for again seismic resistance, low, less weight and prefabricated fast construction. All these are tested at SCRC, and the technology is that it is not that only concept, but they were all tested at various stages, various components, and they can be implemented in the field. To that maturity, these things were brought. So with this, I conclude, and these technologies are already, posters are available in the stalls. I request the participants to go to the stall and go through those posters. The last one I would like to highlight is the very recently bullet resistant security booth. This is very recently developed, and this is also being transferred to the industry. Thank you.
Thank you, sir. The next presentation will be on the topic Building Physics and Materials by Dr. Kishore Kulkarni.
Good afternoon, respected Director Madam, dignitaries on the dais, and the invited guest, my colleagues. Here I am going to present on a sub-vertical theme, that is building physics and material. So as we are aware that global warming is taking place, and because of that one, the main thing is the climate change, which is taking place. And if you see the last couple of years, the temperature of the Mother Earth is getting increased, and which causes a lot of problems, and there is a risk of the risk to the life as well as to the buildings. The buildings which generally we do construct for the comfortable purpose, but because of this climate change increase in the temperature, people are not feeling comfortable, and because of that one we are putting ACs into our buildings, which is creating a energy consumption increase. If you see this some statistic by 2047, the almost 10% of the energy demand which goes to the buildings apart from the industry. So in this case, we have to do our construction as a energy efficient building so that we can reduce the energy consumption. So keeping this into the mind, this in the CI theme, all the labs which are working in the different areas. So the COP26, the commitments what we have given to the what we have given by the country, that is 5 Panchamruts. So wherein the renewable energy is the one thing, and we have to reduce the carbon emissions, and we have to generate the non-fossil generation. So in that case, how we can able to reduce the emissions by making our buildings as a net zero carbon emission buildings. So by integrating the renewable and as well as the passive features. So this is what our goal is. So in case of the goals, we are targeting the CSRI is working not only the architecture planning, but apart from architecture planning, the development of the building materials which are energy efficient, not only utilizing the waste to wealth, but this materials development, we have to go with the low thermal conductivity as a one parameter. So also we have to go analyze the climate change data, because the buildings what we design for today's climate context, but in future maybe because of the harsh again climates, we have to consider that climate into picture, and then we have to design. So innovative materials wherein other labs are working, the smart materials, bio-based materials, energy efficient systems, apart from the architectural planning, that is the passive features, but the integration of the solar power or the wind or the other renewable energy systems into building. And then again, resiliency is also the important factor. We have to go with the climate responsive as well as the resiliency also we have to consider. And then at last we have to get into the numbers of the carbon footprint what we are creating. So these are the some of the publications which we have done in the recent past, particularly the research what we do in the CSRI system. All research goes into the building codes, and there are some building codes which are being adopted by the country, which are basically governed by the research carried out. So particularly functional requirement of the building, wherein the all the thermal comfort standards, the envelope criteria, how we can decide the envelope is better, that means walls or roof, what is the thickness of walls and roofs that generally we need to keep. So all that the guidelines which are given in this particular code. And also there is one particular book is there, that is climate zones and the rural housing in India. So wherein the guidelines which are given with respect to the rural areas. And during the COVID, we have also done the ventilation study, and we have come up with the revised ventilation requirements for the India. And there are some other companion books which are there, which are presenting the different technologies which we have developed. And the PEARL is the another component which is talking about the rural housing. So in this particular the IS codes, as the climate is changing, our studies also, we need to revise these studies, and based on the present content, we have to consider and give to the climatic classification. As we are aware that there are some classifications or the zonation maps are there. For example, for the seismic zonation map is there, purpose, agriculture purpose, there is a climate zonation map is there. But for the building design purpose, there, because we are into different climates. If you see the particularly at present the existing NBC 2005 the climate zonation map, wherein India is divided into 5 climatic zones, that is warm and humid, and the hot and dry, cold, composite, and the temperate. If you see the temperate, which is very small little portion, and if we see with respect to present content the temperate, wherein we can get the pleasant climate throughout the year, but that scenario is not same. In case of the composite temperature of the maybe the southern, from some southern part, if we consider the Hyderabad, and if we compare with the Delhi, in case of Delhi we may face both the summer as well as winter, harsh winters we feel, but wherein in case of the Hyderabad we don't feel. So in the present content, this particular climate map is not suitable. So we have come up with some revised climatic classifications and consider the new the climate data, wherein some mapping is done with respect to 1 kilometer grid. That data we have considered, and some the IMD data we have considered, and we have presented a revised climatic map, and now soon soon it will appear in the IS codes. And there we should aware that what is the optimum wall we need to consider, because nowadays with respect to the prefabricated technologies, some insulating materials which is coming place, but how much insulation we need to plate, based on that some calculation is there. Instead of putting the more thick insulation, which will not solve the purpose. So with respect to thermal admittance and the thermal transmittance value, we have to provide the wall thickness which is for the different climatic zones. The wall thickness which required here in case of warm and Chennai region may not be true for the cold region, as an example of Leh. So we do research in that, and we provide the optimum wall thickness. Also the main particular in case of the our buildings, our roofs are getting heated because of the direct solar radiations. So in that case, the general thing is there, for the waterproofing we do the brick bed cover. But if you see the present content, we wanted roofs not to heat up, so that we can reduce the loads. So there are some products which are available in the market. We do study, we prepare the coatings, we do prepare the insulated roofs and green roof technology. So therein we have test bed facilities wherein do monitor, and we provide the solutions for the different areas which kind of roof is required.
Maybe Kulkarni, another 1 minute.
Yes. So also we have demonstrated the energy efficient buildings which is on the way to net zero energy building. Here in one particular building we have demonstrated, which is considered with the different materials, insulated materials in our campus, and wherein some the active features are also integrated in this. The masonry buildings, as we do study with the masonry buildings, but we also consider the thermal comfort in the with respect to different masonry buildings. Similarly, with respect to prefabricated technologies, because by adopting prefabricated technology without considering their comfortness or the functional requirement, it will not solve our purpose. So we do test our prefabricated technologies with respect to different functional tests, and also we consider the thermal comfort as well. So this is in our campus there are different construction technologies which are demonstrated. We do monitor the real-time performance of that with respect to the thermal comfort. And this is what a slide which shows the how we can do the thermal performance monitoring. So therein we put some sensors, another our lab, sister concern lab CSIO, which are associated with us, and we do the monitor, and we provide the thermal performance of these prefabricated buildings. So at present we are doing climate resilient buildings, wherein as morning some of the panelists were emphasizing that we have to translate this research. So in this particular project, climate resilient buildings, we are taking different climatic zones, and wherein we are demonstrating the climate resilient building typologies, and we do monitor the performance. And also we are coming with the climate resilient design guidebook, so that people in India, they can use that one. And as morning sir was emphasizing that the house typology required for the Assam region is different than this other regions. So based on these guidelines, people can able to construct their houses as a climate resilient houses. So this is what one particular example of play wherein different typologies we are demonstrating in this particular project. Also, we have developed building material atlas guidelines wherein the people of India, they can get an idea from their local region which are the materials they can able to use. We have into development of apps wherein we can able to get an idea of what is the carbon emission, what is the carbon footprint we can get if we do with this type of construction typologies and the different kind of construction mechanism. So we can get at last what is the carbon footprint which is with respect to our buildings. And also now we are into the 3D development of 3D app. Some of the documents which are there with respect to the PAHAL, wherein we are converting that particular document into 3D images so that people can understand how do we construct the houses with respect to the different areas. So therein they can able to understand the 3D, they can visualize the 3D thing, and complex joinery also they can able to make. So with this, I am thankful for giving us opportunity to present on the another sub vertical, that is building physics and materials. Thank you.
Thank you, sir. The next presentation will be on the topic Rural Infrastructure by Dr. Anuj Kumar.
Good afternoon, everyone. I'm going to talk about rural infrastructure, which is a issue to research in CSIR. So I'll be explaining with the concept what is the reason and what is the theory behind how we are working on. So as we know, the population of the world, India this year became the top in the population, in which 36% are in the urban area and 64% in the rural area. And we know as of 2021, the India has the housing requirement of 30 million units, and it is estimated that by 2036 it is going to be 3 times of what is already been built. It is going to be around 93 millions in the upcoming decades. So there is a huge housing requirement in India, mostly in the rural area. And as we know, the construction industry comes with a tremendous expense of industrialization, ecological footprint, and pollution. The construction industry put a lot in terms of CO2 emission, in terms of energy consumption, in terms of embodied energy, which is an energy requirement for any building material from the extraction to the demolition. If we talk about the ecological footprint, if you see the gap from biocapacity and the ecological footprint, how much the earth can give us and how much we can we are consuming. So as of 1961, the gap was something around here. So we had a biocapacity of around 0.42 and the ecological footprint was 0.56. There was still a gap of 0.14. And by 2022, the gap has increased from 0.14 to something like 0.7, which is 5 times of what we already have. We surpassed biocapacity. So there is a sincere thinking requirement how we can match this ecological footprint with the biocapacity of the environment of the world. If you see this map, it is estimated that the business as usual scenario, in by 2100, the world might have limited number of living beings because we are deteriorating and exhausting everything from the environment. As of other business as usual scenario, if we increase the conservation effort, maybe by 2050 or maybe by 2100, we may come back to few living beings surviving together. We need extra conservation effort, extra preservation effort, extra sustainable consumption effort, so that we can soon be back in the ecological footprint point of view. Since 2010, there were several strategies being deployed. Once we realized there is a global warming, there is an environmental depletion. A lot of things has came up. A lot of rating system institute has come up with green buildings, sustainable ideas, and all. But still, it is found that yearly 2% of the energy consumption is increasing throughout the world. That means there is something fundamentally is not going correct. There is a rethinking requirement so that we can go back and have a balance between ecological footprint and the biocapacity. So if we go back to the housing requirement, if we see 30,000 years back, we started from the cave, then we started on relying on the available materials from bone, igloo, and leaves. Then we reached to a place where we call it vernacular or traditional houses, which was completely based on the environment. They were climate responsive, they were energy efficient, thermally comfortable, zero CO2 emission and all. But immediately from these traditional houses, which were thousands of years of practice and understanding, we we reached to conventional houses which were completely relying on synthetic and engineering building materials. If you see the conventional building materials, they are mostly constituted of steel, glasses, and concrete, which again is a major contributor in terms of CO2 emission, in terms of energy consumptions. So we need to again think on the building materials. We cannot just keep on inventing new materials which will be not doing in terms of matching the back capacity and environmental footprint. So, if you see the traditional houses were mostly based on the climatic zone, based on the different climate, different houses were required. So, and like the major, the important one was the coated houses, which evolved in different states based on the climate. They were providing daylights. They were also giving air circulation, ambient temperature control, and all. And each region has their own different kind of coated houses based on the requirement, based on the climate. The traditional architectural evolution was based on climate, environment, tradition, culture, and utility. For example, flat roof appeared in dry region where there was a less rainfall, vaulted roof in the hot dry region, incline in the temperate cold region, and higher pitched when there is a higher rain possibilities in the wet climate region. So settlement was also based on the climate also. For example, if we see in the hot and dry climate, there was a row housing where the walls were common, so that the least circulation of heat will happen, and it was in turns it was giving a thermally comfortable environment. Whereas in the warm and humid environment, the houses were spread out. If you see in terms of colors also, in terms of shades, the dark color absorb more heat. So if you see in this palette, we grow from the lighter to darker shade, we find that the black is the most ultimate kind of absorber and the white is the opposite. The same thing we see in the traditional kind of settlement. If you see for example, the pink city of Jaipur or the blue city of Jodhpur, they were light in color so that they can reflect the heat and they can also be thermally comfortable in the urban area, in the massing area. In another terms, the texture is also a very important, plays an important role. We know the rough texture absorbs a lot of heat, while the simple or shiny surfaces reflects a lot. So, due to the globalization, we are mostly relying on the reflective surfaces, the glasses, which in turn is giving a new kind of problem we know as a urban heat island effect. So that is also need to be considered. Now, if we go back into understanding how CBRI and other CSI lab working in terms of rural technology development. So we have been exploring into the traditional building material. This is example of in Awas Yojana, where we tried with providing a less economically viable and less environment harmful building construction technology for different reasons. It was cheaper in prices, and we also worked on several redefining the floor area of the houses so that the comfortable, as per the ergonomics, the comfortable living areas also been redefined there. These are the states we worked on that time. Different environment friendly building materials were been always worked in CBRI, like precast, local stone lintels, and these are few examples from there. Few interventions also in terms of specifically in terms of what we can do for the wall, what we can do for the plinth, what we do for the roofing system also been extensively researched at CVRI. Several schools has been built in different climatic regions of India based on the their locally available architectural materials. Then recently, what we have started, in the previous presentation you have seen, the Pahal Compendium, which was completely on the local construction technology and how we can give a standard guideline. So it is based on it is been given for the 14 state. It is mostly covering the disaster which the states are facing and how severe these disasters are. Based on that, several typologies has been suggested, and these typologies based on how much foot area and how much cover these are required. This typology also is giving the details of foundation, plinth, wall finish, roof surface, and floor. And a few suggestive plans and sections were also given for different places. Cost estimations will also be suggested in this document. Currently, we are working on the compendium of climate resilient traditional and fusion construction technology, where we have this Bharatiya Awas Sar Sangrah. We have three branches. One is Indian Housing Encyclopedia, which is a climate resilient traditional and construction technologies encyclopedia. Second is the Building Material Atlas, which is a repository of building materials available in India. And third is, the most important is the training manual for the construction skills in India. We have the traditional construction which is being obsolete in the current days because no one is able to understand how we can do it's laborious or it could be have different tricks. So we are trying to document in terms of video, in terms of info manual, and preserve so that in future we can still use it. For that, we have done several surveys. We have selected some representative cities, and we sent across a lot of people around to do survey. The parameters we studied there are mostly climatic zones, construction techniques, local skills, exposure to hazards, thermal comfortable index. If we talk about a thermal comfort index, we found that we did a survey like in comparison with traditional and construction houses. We found that the traditional houses are always being comfortable.
Yeah, you can conclude.
I can conclude? Okay. So, yeah. And we did a lot of survey on our own. We did documentation. We also tried to understand in terms of indoor air quality. In the traditional houses, the indoor quality was much better than the conventional was. That is also leading to the human health, which we saw in the first half of the talk. So if we use traditional building material instead of the toxic, the paint and all, it will also improvise the living standards. And few work from the students also been taken into the consideration for the encyclopedia. Yeah, this is the entire map of the book, how it will be coming up with the different typology, impact calculator, various parameters and criteria considered for that. And the content will be based on the technical drawings, based on the materials, both traditional and substitute. And finally, the simplified construction manual for different climatic zones. Thank you.
Thank you, sir. The next presentation will be on topic mobility infrastructure and planning by Shri J.K. Goel.
Good afternoon. Myself J.K. Goel from CSIR CRRI. I will be presenting the Institute's contribution towards CIE themes, and basically these are the basically goals of the under CIE, and we fall in the area of mobility in the road infrastructure. So this is what the constituents of various labs were contributing in this effort in CIE, and this is the vertical that we are dealing with. And CSIR CRRI is basically involved in mobility of infrastructure for roads and bridges. CRRI, just a brief, we are having these 7 engineering divisions, right from bridges and structures, transportation planning, traffic, payment, visit payment, flexible payment, and geotechnical. So all these divisions deal with the different aspects of road infrastructure, bridge infrastructure, tunnels, pavements, airfield payments, everything, whatever you see in our civil environment, that is dealt by CSIR CRRI. And mobility infrastructure particularly, I mean, these are the various activities, those have been planned, like real-time structure health monitoring for road infrastructure, which constitutes of not only bridges, but the roads also, because we are dealing mostly with the payments. So payment also, it has got a lot of role in the management of overall assets. And then real-time automatic road monitoring evaluation systems that we have to evolve. For the roads, for urban roads, I mean, it is for the entire network. When we call it roads, doesn't mean that it is rural road or urban road. It is the entire road network, which constitutes of expressway, national highway, major district road, village roads, urban roads, everything. And which is facilitated by National Test Laboratory, like National Data Center that we are developing. There is a in Ministry of Road Transport and Highway, there is a portal, that road informatics system. So these data goes to the road RIS, which is being managed by the national highways across national highway by MRTH. And rural roads also they are doing. And of course, these are some advanced technologies like 3D printing. Of course, we have seen a lot of lead has been taken by our IIT and CRC, and we would also be doing this 3D printing technology as far as the bridge infrastructure is concerned. Then, this is very important, innovative road repairs and remedial techniques, roads and bridges that we are doing. And we have several thousands of kilometers of national highway, rural network, which is covered under this roads and repair and remedial techniques. And for this, there is a new IRC code has also come up for rating of the road infrastructure. And waste material, waste to wealth is a theme everybody knows. CRR, I will show in my detailed presentation that how it has come up. Previous slide. How can you go back? Yeah, it's okay. And then these are the basically futuristic area there we are trying to develop. And vibration mitigation and monitoring is also very important aspect, not only for the roads, it is also important for the metro rails. And we are doing a lot of work as far as the metro rails are concerned. Starting with by bridges, which is our main, which is my area of working, and where we see we have developed our own mobile bridge inspection unit, which facilitate the inspection of bridges. Any bridge which is not seen from the arm's length, we cannot call it an inspected bridge. So whatever road bridges or railway bridges, whatever you want to see, you have to approach towards a very, very closer length, then only you can monitor its condition. So we have a patent for this MBIU, we are procuring another MBIU, and our MBIU is total 100% busy. And we have done thousands of bridges through this MBIU, which is currently in Odisha right now. And this is the roadmap which we are following all across the country. And in 2000, we have made a study of the bridge failures, and that is published study. And we see that the average life of the bridges, which we consider 100 years, is not really 100 years. They are failing much earlier. And very surprising to see, even I don't believe this data, they say about 37 years. So, I mean, this is very alarming. It's a very empirical equation which somebody must have drawn from our division. But this alarms us that whether the bridges which are constructed for 100 years are really having the half of the design life. And we do a lot of activities, which is there in my presentation. I don't want to read it. And we are also undertaking the lot of structural safety audit of national highways, expressways. And recently we have concluded a safety audit of Dwarka Expressway, which constitutes of almost 300 kilometers of structural lane highway, which includes tunnels also. These are our various activity under CIE theme. And we do a lot of railway bridges also. That like SCRC has taken a lead. I know they are doing very, very, very good work. And we also did a lot of work on the instrumentation of railway bridges for higher capacity evaluation when they were going for capacity augmentation from CC +8+2. So those work has been done initially by CRRI, and we had done something like 26 or 27 railway bridges all across their zones. These are the real health monitoring that we have done for a number of bridges in India, namely few Ganga Bridge, Varanasi, Mandvi, and all this, and where we did instrumentation right from the well foundation to the superstructure. We have a lot of valuable data available with us for last 25 years. And this is the facility that is coming up with CRRI. This is the facility for testing of expansion joints. So be it a fatigue test, opening movement test, debris collection test, whatever the functionality aspect of the expansion joint is, that we can test in this facility. And I have also seen that railway bridges also, somebody has shown the modular expansion joint. So we have the capability to test the prototype of the modular expansion joint. It may be of multiple strip seal joints that can be tested.
Dr. Goyal, another 2 minutes.
Okay, sir. This is my laboratory where you can see this development is taking place, and finally we will be finishing it off. And this is for Odisha. The entire the bridge network of the Odisha is being monitored by us, including the road network. We have National Survey Vehicle, FWD, where we are basically going towards the scientific monitoring of the road assets. That means that whatever the condition of the roads are in road infrastructure, it should be in automatic mode. There should be no human interference as far as the evaluation is concerned. And National Highway is also interested in developing the performance-based the contracting system, whereby it will be very, very useful. You can see and they are also doing the airfield payment monitoring. So all across the Chennai, Kolkata, Surat, all across the major airports, they are evaluating the airport payments also. Just for the sustainable point of view, our flexible payment has developed a vehicle for the cold mix payment. And this is much talked about it. Even Prime Minister has also tweeted number of times that the utilization of steel slag. So steel slag is being now this is the reality. Number of tests have been done. They are running successfully for last 4 or 5 years. And it has been used particularly right from the subgrade level to the wearing course. So this is the beauty of it. And noise barrier, of course, CRR has developed variety of noise barrier. We are monitoring the noise level all across the city. In Panjim, in Goa state, we have been given the work to monitor there, to develop a noise map, basically, for the state of Goa. This is the urban intersections, multiple urban intersections. We have got number of patents on this, and this has been done quite successfully under the railway track, under the live movement of the trains. Thank you very much. These are the activity in short as far as this CRI is concerned. If anything, we can always discuss. Thank you.
Thank you, sir. The next presentation will be on topic automation and robotics by Dr. Subhatra Mandal.
Respected ma'am, Director CSR CRC and Director CSR CRI, Dr. Sir, and other respected members present here. On the dais and off the dais, I am presenting the brief activities under sub-vertical robotics and automation theme. See, if we look into the CSR, one of the mandate is industrial research. So some of the relevant projects are being carried out under different CSR sister laboratory. At CSR CMRI also we are working some of the work particularly in association with Coal India Limited, that is to watch the underground coal mine, the area. Particularly if you see the area inside the coal mines, it is full of harmful gases. So it's a big concern for human safety and also some fire hazard also. And also there is so many pollution inside the tunnel. So to mitigate this type of situation, and the robotic system is one of the big solution, particularly to develop some unmanned underground vehicle that has been developed at our institute. And in the real-time data, to collect the real-time data, we have developed the robot and tested in the actual field condition. And so in the case of inspection of pipeline, particularly to check the foreign material inside the pipelines. So again, the robotic device is one of the solution, so that where human intervention is not a good idea. So some of the industries like NTPC, we are working some of the research project with financial grant from the institution like NTPC. So in the case of perimeter surveillance, particularly in army camp where it's a desert place, so theft and burglary are very common, and it is required to get the round the clock surveillance to in these areas. So and the robotic system is one of the biggest solution, and also some automation system. So at CSR CMRI, we also done a couple of projects with financial support from Ministry of Earth Science, Department of Ocean Development, particularly to map the seabed with a depth of 50 meter, 100 meter, and 150 meter to collect some oceanographic data like salinity, temperature, and conductivity at various pressure level under the sea. So, and we have developed the prototype, and it has been successfully tested under sea. In case of urban infrastructure also, some of the sister laboratories is working in a number of R&D projects, particularly in inspection of cleaning of tall building and the glasses, because urbanization is taking place at a very faster rate. So regular maintenance and inspection and cleaning is very much essential in this building. So the robotic device is also a good solution to watch this building, to clean the areas and the concern areas. In case of urban municipal issues like that sewage line system, the cleaning, the repair and maintenance is also biggest issue, and human intervention is also not a good solution. So some mechanical automation device that has been developed at our CSR laboratories to particularly to inspect the inside the chamber and also the in situ cleaning and repairing of these pipelines. So in case of that building infrastructure, particularly in civil infrastructure, some of the CSR laboratory like CSR CVRI, they are working in a number of projects under the theme in this one week theme projects, particularly for innovative constructive technology with design flexibility to reduce the cost and also to speed up the building process to enable affordable housing and to minimize the labor intensive work. Now, the first project is that being done at CSR CVRI Roorkee, particularly the glass packet canopy cleaning robot. See, this is a robotic device with a TRL level of 6 has been developed, and particularly the object of this device is for cleaning glass packet at high-rise buildings where the human intervention is not yet possible, and also that it's based on active and passive suction technology with rooftop assisted cleaning system. Now, some of the key features of this device, like say, weight is around 20 kg with a payload capacity of only 10 kg, and the robot speed is 5 meters per minute. So the cleaning efficiency 150 square meter per hour. So it's this device has already been tested at CSR CVRI. Next one is that robotic inspection of ferrous structure. Again, this device has been developed at CSR CVRI. Some of the details of these projects that specifications are already available in the exhibition area. The concerned laboratory people are there, and they can explain the things. But the main objective of this device was to combine wheel and arm location magnetic adhesion for climbing. Actually, it's a climbing robot and with the payload capacity of 4 kg. And this application also is having a tier level of this device already developed, and some of the trials has been taken in actual the field condition with the tier level of 6. Now, yeah, the mechanized inspection and retrofitting of sewer pipeline. Again, this device has been developed at CSR CVRI, particularly to as I told, that to inspect the inside of the sewage pipeline and also the in situ and that cleaning and repair of the pipelines where the human hazards are it's a big threat. So I'm not going into the details as the available in the exhibition area. A gantry robot for 3D concrete printing. Again, this has been developed by at CSR CVRI under this theme project, and this is having a TRL level of 6, and this has been with the silent features like the printing speed of 10 to 30 millimeter per second with extrusion speed of 10 to 50 RPM, and the main it's a precise motion control and purpose is additive construction. Next one is the wall plastering machine. This project has also been developed at CSS CBRI, where this plastering of the wall can be taken very effectively, and for any length of wall around the opening, it can plaster. The power capacity is it's run with a motor of 3 HP single phase motor, with the weight of the machine is around 250 kg. Next one is the remotely operated smart and adaptive robotic system for internal inspection of boiler headers. This has been developed at CSS CMRI, and this project has been sponsored with sponsorship from NTPC. Now we have conducted a couple of trials at the NTPC site, and the robot, you can see the right side figure that goes inside the pipeline to inspect the things inside the pipeline where human intervention is not at possible, and it's a fully computer controlled. All the data can be stored in the computer. Next one is the teleoperated mining robot. This project has been sponsored by Coal India Limited, and we have conducted a number of trials inside the coal mines to get the data. You can see the map of the tunnel map, and also the environmental data captured inside the tunnel, because the sensors are there on the robot, and the cameras are there where we can get the inside picture of the tunnel. This has been deployed in some of the coal mines in Dhanbad area. Next one is that autonomous underwater vehicle. This vehicle has been developed at CSS CMRI, and again this was a sponsored project from DOD, and basically to get the to map the data inside the sea with a meter of 150 meter. We have actually developed 3 prototypes. First one was the 50 meter, then second one was the 100 meter capacity, and then third one was the 150 meter capacity. And you see that we have conducted a number of trials, actual sea trial with a team of scientists. They have done the experiment and the in situ experiment, and also got some few data. Just see that the graphs inside the this seabed that has been captured through the cameras, and the sensors are there inside that whole body of this device that has been fabricated and developed at our institute.
You can conclude.
Next one is that perimeter surveillance. Again, it has been developed at CSR CMRI. Basically, we got it's a robotic device, particularly to get the data from seismic zone, particularly where the level different levels are there in the entire system. It's a fully computer controlled device. And the last one is that one medical device has been developed at CSS CMRI. It's a just to attach in the knee what the load that can be taken care of for while carrying the load by human. The whole body actually the body is affected through this load. So that device actually taking the load. It's a low weight. It's a that actuator with pneumatic silicon tube. Actually, it's made from. It's very lightweight and comfortable. You can see the load can be transferred to the device so that human body is not affected. The last one is the 3D printable data high performance concrete. Again, this lab, this ACRC lab, has been developed. All the details are available in the exhibition area. So I'm not going into the details of these things. And again, another project under this theme is that prefabricated steel foam concrete composite building components for seismic resistance building. Again, this has been developed at ACRC. It's a 3D motor mix concrete that has been displayed in front of the auditorium also, some of the material. Thank you.
Thank you, sir. So the last presentation will be on the topic Waste to Wealth by Dr. Sanjeev Saxena.
Good afternoon, everybody. Dignitaries sitting on the dais and off the dais. First of all, I would like to thank the theme director and other directors for giving us chance to participate in this event. Today, I'm going to present on behalf of Dr. Ashokan sir, who is a nodal of Waste to Wealth Technologies. And I'm also presenting on behalf of all the PIs who have done tremendous effort to bring these waste into the form of waste wealth technologies. I'm also presenting on behalf of other CSIR laboratories. So the first waste that here we have developed technologies in the form of hybrid particle board from agro waste parali. So we are trying to provide solution to avoid parali burning, which otherwise going to emit carbon. So here we are utilizing parali in the form of resource, which is of the order of 500 million tons per year. So this is the process form of parali, which we converted into the form of board, which is of the order of 6 feet to 3 feet. And we have the laminated kind of parali board also having mica sheet on both the sides. So some of the uniqueness are different kind of density, color, texture, and surfaces can be made, and it is also durable. And some of the properties has been shown on the slide, and TRL level is 7, and 3 technologies we have transferred on this particular technology. So beneficiaries are housing and infrastructure sector, and also the local population, especially NCR, Delhi NCR, Haryana, and Punjab. So second waste here is marble granite waste. So in this also we have tried to develop a high performance hybrid composite material from these waste. So hybrid composite material will be in the form of polymer, waste stream, and fiber if required. And also it is considered better than MDF and particle board. So here you can see the kind of the amount of waste that is available. Some marble waste stream in Rajasthan. So we have gone there and collected the waste, and finally we could able to convert it in the form of boards of the industrial scale. And TRL here it is claimed as 6, and we have also transferred technology. And this material is also considered resistant to weather, moisture, corrosion, and termite. So patents also, we got 2 patents on this, and it has multifunctional application. And we have also demonstrated the utilization of this material within our office in the form of cladding material and also in the form of furniture. The third material is bamboo composite material. So bamboo is coming under in the form of grass category. So cutting and transportation is much easier, and also we are getting raw material in the form of bamboo fibers after 3 to 4 years of maturity. So when we compared with in terms of utilization in the form of construction, we have to compare with timber, which is utilized for construction purpose, which is of the having the lifespan of 20 to 30 years. After that only we can make use of those timbers in the construction industry, whereas here the lifespan, the raw material lifespan is 3 to 4 years. So the important feature here is higher stiffness we achieved in this particular material, and also the higher bending strength we got. So that is the reason we are trying to push this material in the form of for construction purpose. So initially we developed 3 feet by 3 feet boards, and afterwards to industrial scale of 8 feet by 4 feet board having different thicknesses. So when we cut these boards in the form of beam, column, and rafters, we can easily make use of this material for construction purpose. So three places in CSR Ampri Bhopal. This is a demonstrative structure in the form of Bathak, another similar structure in Nest Jorat. And also we have demonstrated in the form of flooring this kind of material. So patent also we have filed 3, and technologies also we transferred 3 industries, primarily well as Bhopal, Meerut and Jabalpur. So potential users are construction companies and housing sectors in the form of beam, column and flooring, etc. So after going into this, we found that we have a huge availability of bamboo in our country, and unless and until we developed industrial scale utilization of this material, we could not able to exploit the potential that this material is having. And most of the time, it is utilized at an industrial scale in the form of agarbatti industry. But the problem here lies is 85 to 88% of the raw bamboo is coming out as in the form of waste. Only 12% fibers which are getting utilized in the form of stick. So unless and until we devise some methodology or solution in the form of utilization of such kind of waste, the cost effectiveness of the any technology is not going to happen. So we have also tried working on the utilization of waste in the form of partition walls and also cladding material or sound absorption material, and also a material in the form of souvenir material. So here again, I'm trying to emphasize on the seasonal potential for rural application. So we have expertise of having a sustainable supply of seasonal fiber, and also we have efficient method of extraction of fibers from this. So it has lot of opportunities are there, like seasonal is considered better tensile strength and also durable, and it can be considered as alternative synthetic fiber, and also have a rural job creation and also livelihood improvements. So here it is the process has been shown converting sisal plant in the form of fibers and then yarn and then fabric. So chopped fiber and as well as fabric can be converted in the form of composite material, and also the same sisal fiber can be used in the form of handicraft material also. So another ways that here I'm trying to show in the form of technology is a fly ash based advanced cement free geopolymer concrete for road application. So as we know that fly ash is at least in India it is abundantly available, and also we know the importance of having geopolymeric based solutions. So it is only producing 17% of the CO2 per metric ton as compared to Portland cement. And we also got 3 US patent in this, and also we could able to make high compressive strength pivot block of the order of 50 MPa. We have also demonstrated its use within the laboratory and outside the laboratory also in the form of pavement. So novelty is alkali activators we have used in the solid form. So this is another work where we are utilizing waste and trying to convert in the form of wealth. So another waste is red mud that is the coming out from bauxite industry. So here we have tried to develop red mud based advanced gamma ray shielding aggregate and heavy density concrete. So in the red mud we are adding some chemicals and mixtures, and then we are making it in the form of ball which will be sintered at a high temperature, and then it is pulverized, and finally we are getting synthetic aggregate with a specific gravity of the order of 4.1, and using conventional means we can convert this synthetic aggregate in the form of high density concrete with a specific gravity of 3.6. So we have also tested this high density concrete in the BRC, and we found what we found is it is performing more than 10% to 12% when we compared with hematite ore based concrete. Yeah. Another utilization of red mud we have made with the polymeric base. So red mud has such constituents which can be act as a X-ray radiation shielding. So we also transfer a technology in this. And another red mud application is X-ray shielding material. Here the matrix is ceramic based. So we have transferred this technology to Messrs. Prism Johnson, and we have also evaluated its X-ray attenuation also. And these tiles has already been installed at various places: Indian Navy in Tamil Nadu, Mathura, Rajasthan, Telangana, and also in Ampere. So we have also overcome all the challenges of going for upscaling of this technology. So another important work which I want to show today is development of aligned steel fiber cementitious composite. So here there is an importance of having a longitudinal alignment of random steel fibers in the concrete. So the first one shows the beam casting with steel fibers, and so when we put in the solenoid valve and put current and voltages, these steel fibers get aligned due to magnetic field. So we have also got it tested, and also using 3D scanning image, we can see that the alignment we could able to achieve. So the importance of alignment as compared to random distribution of steel fibers is nearly 20%. There is an increase in flexural strength, and if we compare the energy dissipation of the capacity of the machine, it is roughly double the capacity, energy dissipation capacity when we compared with the random steel fibers. So it has application in critical situation where we want to stop crack growth, such as blast and impact application, and also pre-stress component. Another thing is 3D printing, and we have tested also mechanically the loading direction and normal to the loading direction in our laboratory. So another is antimicrobial coating for fixtures and accessories for healthcare sector. So when we coat stainless steel and wood, we could able to achieve 90 to 95% killing of bacteria, and this has applications in health sector, and also it is silver free, so it is cost effective also, and it is transparent also, and it helps in reducing hospital acquired infection. So this is another important work carried out in CMRI Durgapur, which is integrated municipal solid waste disposable system. So process details has been shown where mixed wastes are mechanizedly segregated, and different form of waste are finally moved into the wealth generation, like organic waste for biogas generation, plastic waste to pyrolysis plant. So 8 different kind of waste to wealth modules are available with this. And these are the places where technology transfer has been taken place almost all over India: Patna, Durgapur, Udaipur, North Chobis Pargana, and it is transferred in presence of Honorable DG Madam and also the SNT Minister. So these are the implementation of technology at different places. Another technology of waste to wealth is a compact vehicle integrated mechanized septic tank cleaning system. So developed by CMRI Durgapur. In this also the solution is on site every time. Here the solution is on site, and also all the processes are without electricity. We can have such type of solution, and it is also been demonstrated to different distinguished guests and also our honorable DG Madam. This is another important work developed by the CRRI in collaboration with IIP Dehradun and some IITs also I came to know. So development of biobinders for sustainable bituminous materials. So a lot of parameters have been studied as compared to natural bitumen. And it was found that VG40, the results are comparable with biobinders, and finally it was concluded that 35 to 40% of this biobinder can be make use of with the natural bitumen. Another important contribution in the form of waste to wealth is ferrochrome slag alternative aggregate for road construction. So a lot of importance are there. It converts natural aggregate and also helps in disposal of solve disposal problem, and also it reduce carbon emission. So different parameters have been studied like water leaching tests. So it comes under the limit of US EPA, and also different parameters have been studied with this alternative grade aggregate with the natural aggregate, and it is passing almost all the parameters, and also different parameters like slope variation and deflection has been studied. Thank you. Thank you for giving me this opportunity.
To express our heartfelt gratitude to all the presenters today in the technical session, I invite our Director, Dr. N. Anandavalli, and Professor Manoranjan Paridas, Director, CSIR CRRI, to felicitate speakers of the technical session.
Yes, sir. Yes, sir. Thank you.
Thank you, sir. Thank you, ma'am. I now request Dr. M.B. Anup to announce the delegates from industry, academia, and research organizations and government organizations who will be participating in the panel discussion in the afternoon.
So good afternoon. So after lunch, we will be having the panel discussion on the topic future needs for civil infrastructure engineering and thing. So our delegates, few of the eminent representatives from academia, research, and industry have readily come forward to give their views and suggestions. So these are Sri Mohan Ramanathan, founder director, ACT Group of Companies; Sri Krishnan, IG Car; Sri P. Ilango, Deputy Director, HRS; and Sri M.B. Siddiq, Director, Technical, Amiable Impacts. So I request them to join with us on the dais for the panel discussion, along with our own scientists, Sri Dr. Saptashi, Dr. Harikrishna, Dr. Kishore Kulkarni, Dr. Goyal, Dr. Subhita Mondal, and Dr. Sanjeev Saxena after the lunch. Thank you.
We'll break for lunch and reconvene here for the panel discussion at 2:50. topic Future Needs for Civil Infrastructure and Engineering. I would like to invite the following delegates from industry, academia, research organizations, and government organization to please adorn the dais. Dr. P. Kamakshi, Dr. Saptarishi Sasmal, Dr. P. Harikrishna, Dr. Kishore S. Kulkarni, Shri J. K. Goyal, Shri Suprata Mandal, Dr. Sanjeev Saxena, Shri Mohan Ramanathan, MD ACT Private Limited, Dr. S. A. Krishnan, IGCAR, Shri P. Ilango, Deputy Director, Highway Research Station, Shri M. B. Siddiq, Director Technical, Amiable Impex, Professor Sendil Selvan, Professor, SRM Institute of Science and Technology. I also request Dr. Kamakshi to be the moderator of the session.
Very good afternoon to all the dignitaries on the dais and off the dais, all my colleagues, respected director. So this is another wonderful day where we all meet together, not only our lab and all the other labs, five labs together. We come together and discuss. We are showcasing our technologies which are developed in line with already future needs. Our DG ma'am is very particular that all the projects are leading to some form of the output. So all the projects are formulated in such a way that it comes out with the product technology. So CSIR is in the correct way. See what is expected from the society. So we are in line with that, and you could have seen from the presentations. So the wonderful inventions made and the technologies which have been developed by our colleague scientists. So we'll just see in a broader sense why the topic of today's discussion is future needs, because everything on earth is need based only. So starting from cavemen, so he started inventing fire, wheel, everything because of the necessity. So it goes by that. There was concrete, it was not adequate, then went for reinforced concrete. It was also not sufficient because depths were more. Then we got this pre-stressed concrete, then high strength concrete, high performance concrete, then all high composites and everything. So everything is need based. So if you look at outside world, during the recent COVID activity, first initially we were not having any clue how to go about it. But if you see, after some time, everything was in place. So we are all tuned to what was required. So after 2 years, we were all able to sustain that, and a lot of innovations happened like that. So everything is need based. So we are able to survive with that. And one difference, you can see that a lot of inventions are happening, innovative technologies are coming up in the market, outside industry. If you look at repair technologies and similar household technology, anything, whatever it may be. But the difference with what CSIR is working and the outside thing is, we are more scientific, we have a more scientific approach. So we go by the validation, we go by whatever we are doing, whether it is according to the meeting the need, as well as whether it is done in a scientific way. That is our approach. So we were hearing in the morning by eminent people, and a lot of issues were discussed on values and how the research has to happen, even if it takes time, even if it is taking a time of 10 years or so. So how it goes from the necessity to achieving all the goals and doing standardization, the scalability, repeatability, and the more than catering the need. So all this standardization, those things, we look at it. So if we look into the future needs of related to this CIE theme, if we see some broad topics like materials in the sense we talk about innovative material, not of a lot, in more number of these things depending upon the application. So those materials from civil engineering and infrastructure point of view should be durable and should be having this anti-corrosive properties, and it should be you should be able to use it for construction with much ease without involving many of the sophisticated technologies. Like that, each one has its own advantages and its own merits and demerits also. We need to work with all the constraints with the new materials, and whatever new material we are having, we should have the testing procedure. We should be able to test it for static and dynamic load and all the cases, and so its performance need to be thoroughly justified. And because nowadays we are going from building in months to building in days. So morning also Professor Gitu was mentioning how they constructed in 45 days, like that. So when you are going for building in days, so you have to make sure everything is in place. So we need to think about so many other things now, carbon footprint and energy, how much energy is involved in making that house or whatever it is. So how it is environmental friendly, how it is climate resistance, characteristics of that, because we have this sea level rising, we have flash floods, of course we have other disasters like earthquake, cyclone, flooding, so many other fire and successive hazards. We have multiple hazards both happening at the same time or successively. Like that, we have a lot of challenges from climate. We have heat waves, and so we need to think about the material, whatever we are using, is catering for all these things or not. And there were another points like rural infrastructure. So if we look into the actual scenario in a rural area, like if there is a rain for 1 hour in Chennai, you will see all the roads will be flooded and there will be huge traffic jam. So if you look at in a rural place, even if it rains for 2-3 hours or half a day or one full night, the maximum what they will face is electricity will go off. Nowadays, most of the people are having this inverter and other things. But there is going to be a cyclone and other things. There will be a huge damage from agricultural point of view. See, not like this population density is one big challenge in urbanization. So we need to think about rural technologies. Means one is some automation. Already in agricultural sector, a lot of automation is happening. And similar to that, in construction sector also, automation is required, because when they are working in a very tall building, people are without safety measures and all that. A lot of people are working. So in those places, if you have proper automation and robotics and those applications will be useful. Coming back to rural thing infrastructure again, there should be proper connectivity from rural areas to urban areas, because a lot of medical facilities will not be there in rural area, and there should be some provision for them to economically be in par with the people who are in urban area. That is one thing. So some kind of livelihood, these things we can, when avenues it can be created over there, so that will be useful for them. Coming to other sensor technologies, I think our colleagues will be talking about that in detail. So nowadays we talk about this smart structures, IoT of things, and uh, sensors, this kind of digital twins. What way it is different from CAD/CAM? Because digital twins will have more details regarding temperature, humidity, and what is the current displacement, stresses, whether there is a crack, or those kinds of information from your sensors. If your digital twin is going to give, that is the additional thing. Like that, we are working. CSIR is already directed towards what are the technologies that is required for today. So we are in line, and now we want to additionally hear from our industry partners. I will request them to give their opinion on what all we are working now. What is your opinion? You first introduce yourself, and you can share your experience with CSIR. If you have already some interaction, you can share about that, and you can give your opinion on what are the technologies that CSIE team can be working on for the next 5 years.
Thank you, ma'am. Good afternoon, everyone. I am MB Siddiqui, short name, full name Mohammad Badruddin Siddiqui. I have been in railways before joining this organization, that is Amiable Impacts. Amiable Impacts, presently they are manufacturing the welding portion. Welding portion is the portion which is used for welding of the track, rail track. This is one of the very old methodology, but it is very interesting. When I have been in railways, I did a lot for infrastructures, endurance, its life. Many of the cases I have seen in the rail track, the failure due to fatigue life. Fatigue life was reduced because of the bad practices, bad maintenance practices. Similar, it can be related to the road and bigger infrastructures also. I am sharing one of my experience. When I joined Western Railway Mumbai, I found more than 450 track failure was there because of the fracture took place at the rail or welding. You might have seen in the track, the welding is joggled with two plates, both the side. And they are joggled by making some bolt hole in between the web, and from that web hole, a crack is initiated and goes either downside or upwards, and it makes the rail failure or welding failure. It was examined that during making a hole, a sharp edge which was not addressed, it should be perfectly chamfered, it was not chamfered. And from that sharp edge, crack initiated. So all the team, entire the railway, it was told that you make it chamfered, and by that simple reason, you can avoid the failure from the website. And many more things similar, having sharp edge, or which was taking the fatigue life very short. In fact, if we are making a building construction, rods are used, TMT bars are used in continuity. They are welded, but they are not properly welded. And during the welding, making the continuity, corrosion takes place. Or if you are making some kind of the layering to prevent the corrosion, it is also destroyed. We have developed in our exothermic process of the welding for a continuity, to maintain a continuity of the rod or the TMT bars wherever it is used in a very short span of time it is used. So it is very interesting that the thermic reactions are instantaneous and it welds anything at site itself. It is not only limited to the track or railways, but it can be used at any place. If you wish that some kind of the welding should be performed in the building construction or the roads where the rods and TMTs are used, this technology will definitely be very, very helpful. Thank you so much.
Good afternoon to all. First of all, thank you for inviting me. So, I am Krishnan from the Indira Gandhi Center for Atomic Research, Kalpakam. As already Madam talked about the environmental effect on the steel and concrete structures, and Sir also has mentioned about the type of loading. So as we so what is important is that we wanted to take care in the design against earlier we do the plastic collapse or the failure in the case of steel structures. Now the fracture mechanics concepts has evolved and grown so well. So we now take care of the design against the fracture where the size of the defect and shape of the defects present in the structures determines the life of any structure. So what I hear now for towards that to minimize our the defects, we are coming up with a 3D printing technologies in the both in concrete and metallic structures, which we expect that minimize our defects in the structures. And even if exist and we under the different type of loading, whatever we see the static, dynamic, or the creep fatigues loading, what that is and environmental effects. This leads to a degradation of the structures. What importantly, we need to monitor it, condition monitoring. So we need to have really come up with the non-destructive techniques which can detect the condition of defect in the bulk. So example, today also I saw combining a technique of digital image correlation and with acoustic emission. So where the digital image correlation technique will give you a surface defects, how it's going to affect your structure. Acoustic emission nowadays, last 2 decades, it's growing fast and people are trying to combine with other techniques and adapt it to find out the health of the structures. So what I means is that working towards this non-destructive and condition monitoring technique, which is one of the important area we can choose that. And I mean, we need to see that is at the specimen level and the large component level, how we will implement this and monitor the structures. That is one. So that, thank you. Maybe,
Is there any person from Good afternoon to you all. I thank the director, madam here, to put me on stage, though I wanted to sit on the chair. I'm from industry. I've got about 45 years industry experience. And I suppose whatever I say now is on behalf of the construction industry. The labs are doing excellent work. And you will keep doing excellent work. How much is being absorbed by the industry, by the public, is a question. Newer technologies, at least 10 technologies I saw from the field, from your research labs, you have transferred a few to the industry. But is it being accepted at large for the society to benefit? How much of the society knows about what you're doing? Why are we not having startups
in civil industry. Very rare to find startup. Today the word startup has come. During my days that word was never used. So why there is no startup, the word that is being used today? You go to research park here, maybe 1% is connected with civil engineering. So what is the core reason? We have so many good labs, excellent scientists, well-funded research to benefit. Sorry, madam, I'm a little critical, cynical. It's okay, because the industry point of view. So we must ask ourselves a question: why are we not motivating civil engineering startups? There must be a reason. I have a few reasons to say, but this is something that all labs. I've been coming to SCRC last 40 years. You have excellent research done, papers published internationally and other conferences, but does it translate to society benefit? My interests are, as you all know, I'm a demolition guy all over the world. People come and see what I'm doing, and interest in concrete and in deep foundations. But take the case of just two products that we know very well, steel and concrete. Where are we 50 years from now? 50 years from now, where are we on concrete field? Enormous research has been done by my alma mater, IIT Madras. How much is being used to the advantage of the society? You can check with any big developer. Leave out the top 20 companies in India who have access to the best technology. The bulk of the India is not using, they are taking advantage of the technological advancements in concrete. We have reached 200 MPa ultra high performance concrete. When will it reach the common man? Even in Mumbai, there are 1 or 2 buildings only who have accepted to do UHPC on a very tall 100-story building, only because the column sizes are low, has become smaller. Reinforcement. I think we have deteriorated in the chemistry of the steel. Why does it happen? Just not the strength. We are not bothered about strength. We know how to design for any steel. But the steel we get today is already corroded when it comes to the site. Already it's got cancer. Then we try to protect it by so many things. Why? So we have not improved in these 2 basic materials. Concrete, we still do not have an alternate to natural virgin material. We are still depleting Mother Earth. So after 50 years of research, we are still going to the granite quarry to break the mountains. All the research we are doing on C&D waste, alternate aggregates, all at the lab level. Show me one plant in India which says we supply only non-standard materials, which is non-virgin material. I don't think there's even one plant which supplies only this. Public don't accept it. I'm trying to push C&D waste. I'm part of the 2016 rules, but still the actual owner, the buyer of concrete says, why should I use this? I'm doubtful to use C&D material as virgin concrete, as in my concrete. So public at large are not benefiting by the C&D waste research that we've all done. CBRA has done enormous work. We go to conferences on C&D waste, but it is not accepted by us, public, even including me. So there is a lot of work to be done from lab to field. That bridge is missing. We have made tremendous strides in other, but it's probably within 2 days back, I had to pour 300 cubic meters of concrete. I insisted that we use only GGBS instead of fly ash. There is not a single RMC. I'm being very practical and I wanted to share this, the reality. Though we talk about sustainability, low carbon footprint, so many things we talk here and similar forums, near Kumbakonam, there is not a single RMC who has ever used a GGBS. So where is the knowledge going? They have good ready mix plants. It will take another 50 years for them. They're using fly ash, but not GGBS. They never heard of it. But I insisted that you use only GGBS. So they moved, emptied the silo. It takes a lot of effort. So there is no point talking about low carbon footprint, green concrete, when it has not reached the people who are going to use it. Steel, when I chose the steel, it was a 500-year guaranteed structure. 500-year life I had to sign. There was nobody who will give me corrosion-free steel. Though they say it's corrosion-free, it's not corrosion-free. I had to go for galvanized steel at 25,000 rupees a ton extra. There was no other alternative. Where is our research on steel? Why can't I buy steel which will have a life of 100 years guarantee? 100 years back, British brought steel from England. I demolished the Basin Bridge Tower 100 years ago. Not a spark of corrosion in that mild steel. After 100 years, I still have that with me. So where have we researched? Where have we gone in the direction of materials? I'll stop here, ma'am. No, I'm not here to give a lecture. But my thoughts from the industry is we must give to the industry, to the society, value-added materials from your research. Public should demand that I want this steel, I want this concrete, I don't want carbon, this carbon footprint. All that is good in research. Professor Gettu was here, is great advocate of that. But we must go in that direction, ma'am, and other scientists. Whatever we produce from the lab must be accepted by the public and must benefit the society. There are a lot of doors to open. Industry, they have to accept, they have to. So that will happen. But from your part, I think there is one role to play is bridge the gap between a good product that you have brought in and a startup who will take it up, and then the society will benefit. Pressure can come from the society also, demanding such a product, but that requires a lot of education. Thank you. Thank you for your time.
Sir, let me respond to you.
Yeah. No, I didn't ask any question. It's okay. Please.
Hello. Yeah. Thank you, sir. You are very right, sir. Whatever your observations are, I also feel it because the issue here is the transition time. It takes a hell amount of effort to get anything translated from research to the standards, first of all, because it is the government who has to first accept before the public accepts the development of codes, standards, because anything that you do in the public domain, your acceptability has to be through some standards. So like standards like BIS, IRC, for roads specifically. I mean, but I have seen during last, you can say 5 to 7 years, there has been a lot of transformation also. I mean, like this GFRP bar. Now there is a code available. The issues are there, but codes, nobody can restrict you. Moment there is a code, you can use it. Similarly for CNT waste. For CNT waste also now standards are available. So what I am finding, the standards are now becoming available. Whatever is being done in research, this is getting translated at least in the form of standards or certain guidelines. Like I am doing a project on bridge deck waterproofing, and ministry is very keen. Okay, it may take a few years to make a code, but at least we can make certain guidelines where at least it can be deployed on trial basis, on pilot basis, something so that our engineers are not in trouble if it fails sometime. So that way it is improving. And certainly public mindset. Public mindset is very difficult to change. If suppose you are constructing, suppose I am constructing my house, I would certainly not like to take a so-called, the modified materials, if I am 100% sure. Because first government has to accept it. In all government projects, like you see earlier, we used to make this, we used to make a lot of use of woods. Now it is replaced. It is replaced because CPWD issued circular, okay, no more wood now. Use only your plastic frames or concrete frames or whatever it is. So that way, if government itself takes up this, like metro is coming up. If metro start using this DGPS, and definitely public will, then they can show us, look, this pillar is made of DGPS. It is right in front of you. So that way it has to be seen. And I believe India is a country where, slowly we are growing. Actually, mindsets are very difficult to change. And still, I agree, 100% agree with you. We have deteriorated in steel manufacturing just because we have lifted the embargo of primary steel, or that kind of the terminology has come because of some. Re-rollers, because of the onset of the re-rollers, this whole entire steel reinforcement industry has really given us a lot of embarrassment. And you see a lot of bridges now they are in the danger of collapse because of, especially in the coastal region. And there is something very, very wrong, and government has to take some action on it. So that I accept your answer. And in civil engineering, it's very difficult to make a startup because you pointed out the startups. The startups are easy to come in the field of consultancy. And civil engineering, you need out and out a contracting system. And because of the huge money involved in the contracting system, only small startup can come. Like for instance, today I was very impressed with Professor Getu presentation on GFR paper, and then this 3D printing. So before 3D printing, I was mentioning to my colleague, why we are not succeeding in the precast panels. See, precast panels are there for last 30, 40 years. There was a company in Siporex in Pune, that is, I think, something like more than 35 years old company. And still, we are not seeing so many precast construction. Though it appears to be very, very convincing and very good, and public is also very convinced. If you have a precast wall, precast columns, precast, these components, beams and slab and everything, in a multi-story building, you can always use it, and it is better than your conventional kind of thing. If that is not coming up, that means there has to be some reason. And sir, basic reason is cost. Basic reason is transportation cost. In sir, National Highway also, because I worked there, we try to standardize the span length. We said, okay, all our structures like ROB, the flyovers will have some standard length so that we can create small stockyards. So suppose there is some construction going on in Chennai, we know, okay, this is my material requirement. This is my span length requirement. This is my structural components requirement. And accordingly, I can plan my DPR, and accordingly, I can make the construction. But that has also not come up. Why? Because of our contracting system. So there are systems in India which are not working. We are a society where we say, okay, we are doing a lot of things, but when it comes to implementation on contracting system, now we have an era of performance-based contracting, sir. Now gone are the day where you have to make roads on BOQ basis. Now this is performance-based, where your certain performance standards are defined. But then there is a competition war. There is a cost war, basically. So unless we, as a society as a whole, do not thresh out certain basic issues at policy level, your technology advancement comes later. So there has to be some policy intervention very, very seriously. Look, this is how we want to step ahead. This is how in this system, like we have brought sleepers in the railways. Earlier was the wooden sleeper, then steel sleeper. Now there is PSC sleeper. There could be FRP sleeper. So unless government makes a policy changes, major policy changes. Look, we don't want this kind of steel at all. Ban the plant. We are talking of pollution, but we are not banning the polythene. Unless we take such policy step, things are not going to improve. And I hope, because research are available. I mean, lot of, if not available in India, it is available outside. We need not to copy their research here. We can straight away adopt it. Ministry has issued lot of circular to give you test stretch. They simply say you bring international technology, you show the performance of that technology, and you implement it, and we take the risk. What else government can do? So that way, I mean, I think things should be working, sir. Thank you. Anybody else?
I want to, yeah. Somehow now it has picked up because there was no other alternative material. So natural resources we cannot reproduce anymore. So sand has come into practice. Now everybody has accepted. Like that, something has to happen from aggregate side also. If that is done, then people will accept.
But the cost of sand. Again, the question is the cost. So, the cost of sand is too much. I remember somebody had imported the sand from abroad some years back.
But natural sand is also
obviously, but you have to accept with the cost of it.
See, if all of us agree that the steel has deteriorated and that is the cause of the corrosion. There's a lot of research going on in all the institutions across India on corrosion protection, but we talk about concrete. Concrete is not the main cause. I'm a founder member of Indian Concrete Institute. We have so many meetings on corrosion resistance, but you don't call a single steel supplier. Steel is the culprit. Let us understand that unless we change the composition, chemical composition of steel, they have reduced the chrome so much. We are going to have this deterioration. Because I'm involved in demolition of buildings, 10 years old building in Chennai, 3 towers. 10 towers in DDA going to be demolished. So many of these house owners with the hard-earned money, they are displaced. The reason is corrosion. Go into that reason, it is steel. Okay, a little bit chloride content was there and use of water, but the culprit, why are we not addressing that public? The culprit has been re-rolling mills, as he rightly said. They only talk about we have such high-strength steel. We don't need high-strength steel. Such high-strength steel. We never use it in our RC design. So let us at least, those of you who are here, ask this question when you buy an apartment. What is the steel you have used? Can you sign a bond for 100 years? There will be no corrosion. No developer is ready to sign this. No developer will sign a bond saying there will be no corrosion in my building. The minute we start asking this question, we can make the change. I don't know. Somewhere we have to be, it is your money that you are putting in. Go to Saligram, 700 families are being displaced because we are going to demolish this building. IIT Madras given a report. Building is unsafe. I've inspected that building. What did the residents do? Nothing. They only bought the apartments. And more such will happen unless we cure the disease causing steel. I hope if there are steel manufacturers here, I'm ready to answer their questions.
No, sir. Thank you very much. You are a very right point, sir. In fact, all the builders, whoever is, they go for cost cutting. From where they can cut the cost, they will go for. Whether it is your cement or whether it is your steel. But the steel being the culprit, as you said, because of the corrosion, is very correct. Here, high tensile TMT bars and all these things, they are including into the construction of the building and all. Whereas they should look towards the anti-corrosive. Whereas the anti-corrosive steel will involve some kind of the alloying element like chromium, copper, etc. That the steel cost will go up high. And nobody is going to buy it. So no manufacturer is going to manufacture it. This is the what. If a standard is made in such a way that corrosion-free bars should be used, then only this can happen, what you are saying. You are very much right, sir. But here is a question of cost. That is why I have once to the Secretary institution, not here, that's correct. have developed some kind of covering, enamel covering and other covering. If it is destroyed or damaged by pressure and by weight of the concrete, then it will it's again. But that is again a cost. It includes the cost, more costlier. But by the time SAIL, Steel Authority of India, they have developed a rail which is corrosion resistant for rail itself, because we have been faced in the coastal area, a lot of corrosion in the rail track is taking place. So to address that, they have devised some methodology and chemistry using chromium, copper, nickel and all to reduce the corrosion. Similar way, if it is done in our structural, then it will be able, so one can take guarantee for more than 150 years, not 100 years. Thank you, sir.
One suggestion I have from the industry is you have good products developed, bringing up to the doorstep to commercialize. Why can't you have a 10% partnership with a startup? The advantage, whether the labs do not, if you're not allowed, then you have to appeal to your Director General to allow it. Then the startup will have the confidence of a constant shaking hands with your lab or with the inventors. Just a 10% startup for the lab, the CSR lab from whom you are giving the knowledge for the startup. Balance 90% capital will come from them. And this will give confidence to the startup, a youngster with money, so that there is a handholding throughout the career. I know it's commercializing research, but I think that could be a simple bridge where you can advertise, have an open day only for industry, show what you can after this policy is made, and you can sign up. This is being done in the US universities. Very, very clearly, US universities, not just in civil engineering, but in pharma research, scientific research, they have the stake in the new startups.
Sir,
Just an idea.
CSIR also we have a policy of technology transfer. So once
Money,
the technology
partnership.
is transferred,
I'm asking, partnership is
in the
different.
sense
The
we are-
confidence level of the startup will go up. He can say, I have a startup who will not leave me because you got money put inside.
Yes.
This is what I'm asking.
We are not
You can,
thoroughly into marketing, but still we whatever
I think all
technology
these
we
labs together, if they say, better utilized unless otherwise your product and patents are just sitting in the shelf without being used.
Yes, sir. That is also one of the policy of CSIR, and many of our technologies are transferred to industry, and even you can see that that polytol building also has been transferred to L&T, and L&T makes that kind of product on their own, and then they use it for their purpose, but for commercial purposes they are not selling it.
No, please
so we are not,
don't take L&T as giant. I'm talking about a spot. I know so many civil engineers from rural villages who don't know what to do. Their parents want them to start industry, but they don't know what to do. That is the reality. So you need to reach out to them. They will never come to a city, come to your lab and then sit with you, say what technology is available, what can I buy. But if you become a partner, the confidence will go up. I think industry has to have a money partnership instead of just technologically signing.
Yeah, I think, sir, yeah, that is, I think, related to incubation centers, policy is there, but not to the level of going to the rural, but wherever the institutions are there, they want to create the incubation centers to support the startups actually. Policies are there and they are being implemented in selective fields where the prospering technologies are there. But civil engineering, I am not sure. As you rightly said, IIT Madras, 1% is only civil engineering. So encouraging even civil engineering subject is itself, I mean like a dry field people are concerned.
My name is Dr. Paul. I am the in charge of Central Electro. Hello. Yeah, my name is Dr. Alok Pal. I am scientist in charge of Electrochemical Research Institute, Chennai unit. So, since you said we need to have a partner while we do our research work, in fact, in CSIR, at a headquarters have a program called New Millennium Indian Technology Leadership Initiative. What it does is it brings industry origin these projects which industry can actually send projects which are industry oriented projects, industry originated projects, and then they can choose a CSIR lab of their choice, and not only one lab, it can create a kind of multiple labs. So it can happen that one industry comes up and says that I want to do a work where industry along with CSIR labs can work together towards a goal. In fact, I have participated in such a program. To give an example, Mahindra Reva wanted to do some work. They wanted to bring a car, and we actually helped them with the battery part because that is the electrochemistry there. Mary Durgapur helped them with the design of the chassis and the platforms, and there were other labs also involved. So CSIR, it gave a funding which was in the form of a soft loan to the industry, and it gave us a grant to CSIR labs to work for the project. So there are existing programs where industry can partner with CSIR, and more than 200 projects have been funded in this mode. I think we have to do on our part more to popularize this program so that it should reach more industries and more entrepreneurs so that they can use this vehicle to work with us.
Partnership and then start, and they can be part of it. There is a system scheme existing in CSIR. So if the scientists are coming forward with their technology, I think it is possible. And also some policy reforms, as you were asking about the startups, some policy reforms are going on. So we will shortly, that kind of thing is being worked out. As of now, it is not there, startups are not there, but there is a policy reform is happening, which will shortly come so that we can have that kind of startups also. In civil, I think it is, startups is nothing but starting a new business, which is maybe all of you, like maybe your father would have started like a startup only, like the company. So similar kind who wants to venture into and take the technology and try it out, it is possible still.
Yeah, actually, just want to say one thing regarding sir's question. That I think our DG ma'am actually recently introduced all the theme project, all the mission-based project, where now one industry partner is included in all each and every project. From the starting of the project, the initial stage of the project, not in financial part, but only the technical things they can contribute something, so that it gets a big success at the end of the day, the project. So industry, we are doing all the finalize the specification for a particular product or process, taking consultancy from the industry partner from the very beginning of the project. Thank you.
Yeah. Okay. Good afternoon, everybody. I'm Dr. Sendil Selvan, professor in the Department of Civil Engineering, SRM Institute of Science and Technology, Kattangaluttur. I was in the teaching for the last 26 years and also in the research. My area of research is steel concrete composite structures. I have completed my PhD in Anna University. Coming to the topic futuristics in civil engineering, considering the steel concrete composite structures, the thrust area, I am interested in the CFST side, that is the concrete infilled steel tubes. where we can achieve the strength whatever we require. See, since it is a concrete infilled steel tubes, there is no formwork is required. And also, the steel and concrete will combine together, it will take the load. If you want, you can go with the steel reinforcement inside that, or you can. It is not even it is not required. And one more thing, when the steel is outside and concrete inside, the steel and concrete combine together, and it will take the load combinedly, both axial and eccentric load. And the surface between the concrete and steel will have sufficient bond. That can also be tested, because I am also doing a lot of research on this area. I can give some of my result for considering the futuristic area in civil engineering, so that you can achieve the good bond between the surface between the steel and concrete to take the load. This is the one point in steel concrete composite structure. And one more steel concrete composite is there, that is concrete is encased, steel is inside. So in which you may ask, what is the difference between these two? In the first part, the concrete steel is outside, concrete is infilled, hollow section. The another part, the second part, steel is inside, concrete is outside. Concrete is encasing the steel section, where you have to go with one advantage is there and another disadvantage is there. You have to go with a formwork. But concrete will take more large amount of heat when compared with the steel, you know. So when it is encased, the concrete will take more amount of temperature when it is required, where the more amount of temperature required, you can go with this kind of steel encased, concrete encased steel structures. And one more thing, I have tested a lot of specimen as a column, as a beam in the laboratory. I found the ductility of the CFST columns are increased when compared with the ordinary reinforced concrete column. Similarly, the lateral deflection, or you can say that buckling behavior, is also delayed when it is subjected to axial or eccentric load. That was in the concrete, that is concrete infilled steel tube columns. So this is my point of view. I want to insist, considering the futuristic in civil engineering, in the field of concrete composite steel structures. Okay, that's my point. I want to share it to you in the academic point of view. Okay. Thank you.
Hello, good afternoon, everybody. I'm Saxena from Bhopal, a CSR man. So I may be more critical to the extent always as a scientist, we are always complaining that industries are not coming forward to accept our invention and many other such kind of excuses we are always putting as a scientist and always blaming on the industry partner that they are not, the environment is not conducive enough there to get encouragement as a scientist. But before claiming that we have developed any technology, are we that much confident to buy our own technology? So the situation is like that. If any scientist is claiming that he has developed some technology, let us ask a critical question: are you ready to purchase that technology? So first we should be more realistic to ourselves before claiming anything. And most of the time we are putting FTT kind of thing, and the end goal is industrial application of that knowledge. But first thing we should ask the inventor himself to him, are you ready to take your own technology? So that is the biggest dream, that our own developed technology should be taken by the inventor himself. And there is a system in CSIR, and we have such an incident in Bhopal that one of our scientists, after retirement, during the we have policies that during the service period you can take 2 years of service to start the startup, having your own intellectuals. But most of us are very playing always on a safer side. So the best would be that after retirement, whatever we have worked or whatever we have developed, we should dare to take up our own technology and after paying a price. And we have such a successful story in our institute that one of our scientists who developed one technology and finally he purchased that technology and finally become entrepreneur after retirement. And as a scientist, we are also very poor in calculation also. We could not able to get the real cost or the manufacturer cost, how much it is going to come. So these are some of the things. And see, today I talked about waste to wealth. So most of the time we feel that waste is or all the raw material is coming free of cost. But what is the reason these things are not going finally in the form of actual product in the market? The reason being that the amount of processing process development or whether those ingredients extra matrix that we are utilizing for making material, are they that much cost effective? The moment the thumb rule is like that, whenever we are using more than 10% of the matrix and remaining is 90% is the waste, that if we are utilizing that, then only it is a cost effective thing. Whenever we are proposing more than 15% polymer and 85% filler, it is not going to be cost effective. So these are the critical things we should evaluate whenever we are evaluating any project and giving funds to different inventors. Unless and until we check there itself, that time itself, we could not able to get more successful stories even after 5 years in this theme or any other theme also. And another thing is there is a important requirement of having self-deployable structures under severe condition. So under severe condition, so
Dr. Saxena, just
please.
we'll give opportunity to the outsiders. Maybe one good takeaway from Dr. Saxena's thing is all retired scientists should start startups. So we should become entrepreneurs. That is the positive note we take from your thing, and we'll go ahead with that. And I thought other.
Good evening to all. I am Milongo from Highways Department, working in Highway Research Station. At present, 74,000 kilometers road network in Tamil Nadu, 143,000 of bridges, including small culverts and all. Government of Tamil Nadu at present announced in the recent assembly session, separate bridge inspection unit for Tamil Nadu. There are a lot of scope for the scientists and engineers to work with government of Tamil Nadu, particularly inspection in a scientific way. So at present we are having some inspection techniques stipulated by the IRC. Now we are going forward, for example, structural health monitoring and all. And another thing is Ghat section, for example, Ooty and Kodaikanal. Recently we come across the landslides. There is no system for monitoring the landslides, particularly for the retaining walls or bridges and roads in hill section. There is also a research area to be focused by the civil engineering field. Thank you.
Just a quick comment on
Thank you very much, sir.
In Odisha, actually, same way the Odisha government has also thought of, and they are doing about 4,000 bridges, the scientific evaluation of 4,000 bridges, and their road network. So CRRI is actively involved in roads and bridges, and definitely you would also find some mechanism where you can also, I mean, take a tip from the how Odisha government has approached all this issue. That is my small suggestion, sir. Thank you.
Yep. bridge evaluation, SERC is also playing a big role. We have also access to this bridge database management system from Moorth. We have collected about 3 lakhs data of highway bridges. And our scientists are well versed in monitoring as well as condition assessment. Condition assessment is one key strength point with SERC. Most of our scientists are traveling always to NTPC and other very important structures, investigating them and giving the solutions. So you can also connect with us so that we will also be part of that in bridge evaluation, strength evaluation. Thank you.
So I am Saptarishi. I am from SERC. In the morning, I was presenting about a structural meeting. After listening to all of the things, I would say that actually we are at a different stages, because that if I take an example of the material, I think if I am not wrong, that the use of the fly ash for concrete, I think it was originated, and it was with the effort and the endeavor of SERC. It has gone to the CPWD manual. After it gone to the CPWD manual, it has been now used for. So that having a persistent effort and the use, and by backing by the very founded research, I think it is a requirement. And some of the areas, actually the industry is not so sluggish. They come to the lab and to get into the things. And as Sir was saying about the acoustic emission, DICs and all, even the railway is going much faster than us. They are telling us that you should come out with a much advanced technique. So it is not only the research, because the industry also is looking forward to get as advanced as possible, so that if we handhold and be always relevant to the subject, based on the requirement and based on the particular topic, so something can go fast and something can take some time, but it will be definitely, it will be going to the society at the end. Yeah, I just want to mention that.
Okay. Myself, Kishore Kulkarni. I am senior scientist working in the Department of Architecture, Planning and Energy Efficiency in CSRI CBRI. So my point of view with respect to future needs in civil engineering with respect to energy. Actually, as we know that energy demand is increasing. So with respect to that, we have to think how best we can able to do our construction which are energy efficient. So there are two things are there. One is the retrofitting of the existing structure, and with respect to future construction, considering the green measures what we can provide in the newer construction. People are talking safety and strength and speed of the structure, but people must talk about the energy demand, because operational energy during the service life, the buildings operated through energy. And there are cases in Chennai also, as well as in some of the cities now, people are thinking of the energy demands, and based on the energy needs of that particular, in case of the apartment buildings, the prices are being fixed. So if any operational energy of particular apartment, corner apartment, if it is less, which is selling at high cost. So people should look into the energy aspect of the building with respect to operational energy. And as we are, sir is pointing out, we are working on the materials. So in case of materials also, we have to consider the different materials for the different climatic regions actually. And we have to tune our materials with respect to that climate. We have to look into the smarter materials like phase change materials. Also, we have to consider the materials which are low carbon emitted. Also, there is some of the technologies in case of prefabricated that CO2 sequestration is there. So we can utilize CO2 for the carbon sequestration of the concrete products, and that kind of products can be used so that we can embed it CO2 permanently into the concrete elements. So there also some of the things we need to do. And third aspect is with respect to the renewable energy, like government is taking a lot of initiatives with respect to the solar rooftop, and we have to utilize, because we belongs to the tropical country, wherein from south to north region, even though in Ladakh, we are getting abundant solar system throughout the 12 months. So we have to utilize and we have to integrate solar systems into our building so that we can get use of this particular energy. The sources from ground sources, wherein geothermal is there, some kind of geothermal systems wherein we can easily get the ground energy So these kind of systems we have to integrate in our building so that we can able to self-sustain our buildings with respect to the energy demands. So that is what my thought on this. Thank you.
I have got some of the fatigue and fracture tests of the components done here at SCRC. And my other colleagues are also getting it done from SCRC, a lot of under collaborative research project, this thing. So now that to minimize the pollution, we are keep increasing power plant operating temperatures. We are coming up with the advanced materials. Now, qualifying and testing of these advanced materials components in the larger scale is a requirement will be there in doing advanced ultra supercritical projects or the high operating temperature equipments are going to come up. So establish availability of facility to carry out large size components at high temperatures will be helpful in future. That's one point I want to say. Thank
you. Yeah. Myself, Hari Krishna. I'm heading Wind Engineering Laboratory working in disaster mitigation for infrastructure thrust area. I just want to add based on some of the concerns expressed by industrial representatives so that whatever technology is being developed, one is government has to accept and another is public has to accept to implement it. I just want to quote one example. SCRC has developed EPS prefabricated technology and it was transferred also. And after transfer, the people who have purchased that technology, they constructed one colony near Visakhapatnam. That is after post-cyclone Hudud, government wants to give shelter, new housing to them, people who got affected. And government also came forward that they want to use the alternative construction methodologies. Actually, it is very encouraging thing from the government side. And one of the technologies chosen is this EPS, and they have implemented colony. During construction, the people watched the construction, they noticed the thermocol being used. And they were so concerned that, what is this, you are constructing a house for us using thermocol, how far it is going to help safety is ensured. So all these things should be eliminated. One is government is coming forward to implement the alternative technologies, which is very, very encouraging thing. But at the same time, public is also should be made aware that they are foolproof, and a lot of confidence should be built in their mind so that it become popular. Like 3D printing now, I think initially people have got concerns now, but the small units, it has become so popular that the people are opting to go for cost-effective and fast construction. I think all the other technologies also, I feel it should be made in such a way that one is government coming forward, encouraging them, another is public concern should be eliminated. I want to conclude with this. Thank you.
So I think now this is the time to close the session. So the takeaways, what I see is, one is steel quality of reinforcement. That is a very valid point which have been discussed here. So this has to be taken to other forums also, because that is not in our research area. So some other CSIR laboratory also, NML or some other laboratory, they can take it as this thing, and they can come out with correct constituents which can make the steel non-corrosive or better non-corrosive, or those things. Some research focus can be there on that. Another one is prefab building that was discussed. So why it is not popular even after 30-40 years? See, one concern is the joints. Joints are not fully proven. So even though it may be good for static loads, for dynamic loads, even for earthquake loads and other things, joints, still there are some doubts and other things about that. That may be one of the reasons. Another one is handling equipments. So to handle it in the site, cranes and all those things are required. It may not be possible for a small builder, or he may not be able to afford it. Other one is cost, depending upon that, and durability issues. So how whether climate resilient properties and other things. Another one is waste to wealth part. This recycled aggregate, why it is not popular, that was discussed. So we may hope that someday it will happen, like M-sand has been a reality now. Some this biomass-based aggregate or recycled waste-based aggregate, coarse aggregate, sometime it may become popular once it is proved. So that's what we hope so. And one important point which was given by our Krishnan sir from this one, there should be qualifying tests that needs to be done on the new materials and technologies, whatever. So the test requirements. So there should be enough test facilities for doing this scaled models, or with the full scale models. There should be facilities created to carry out the test. As far as CSR labs are concerned, that is one of the major strengths, you can say. To certain extent, we are able to do this kinds of tests, seismic qualifications and other things we do. We carry out test as per the standards. And this bridge retrofitting, that was also discussed, that was the requirement. And energy requirements for a building. So that was also discussed. So these are some very good points that we can, that has been discussed in this forum. With that, I think we can close this session. We thank all the participants. Thank you very much, sir. Yes. I thank Director for giving me this opportunity.
I thank one and all again for participating in the panel discussion. To express our heartfelt gratitude for the presence of our delegates from industry, academia, research organizations, and government organizations, I request our director to present a memento. I request our director, madam, to present the memento to Sri Mohan Ramanathan. Sir. Dr. S.A. Krishnan from IGCAR. Shri P. Ilango. Shri M.B. Siddiq. Professor Sendil Selvan. I also request our director, madam, to present the memento for our moderator of the panel discussion, Dr. P. Kamakshi. We'll conclude now. Okay.
I thank all the industry people who have participated and gave their views, and some of which are leads for us to take forward, not only by SCRC but other labs who are here presented here. And I would like to convey my regards and thanks and appreciation to the organizing team, Dr. Hari Krishna and his team for all the efforts that he has taken today. That outcome of what we have seen today, he was working for past 15-20 days, and we have seen the outcome. I'm not reading out the names. He is the lead, and there are a number of people who is behind him. Thank you, everyone.
This brings us to the end of today's event. I request everyone to visit the exhibits showcasing various technologies at CSIR, which are displayed outside, and I also invite everyone to visit all the laboratories and experimental facilities at CSIR SCRC. I thank each and everyone for joining us today and making this event a grand success. I request all to join for tea at the dining hall.